found out why the I was dropping frames yesterday. It's because Windows was updating, probably installing some kind of an AI something, so that all those tech giants can masturbate over who's using AI for literally every job, not just ones that it's good at. All right, let's see. Whew, it's a scorcher today. It is hot out. Took the doggy for a walk, and I am not in good shape. My whole body is sweating. I think we're gonna do a little bit more testing on this 303. I did some reading up this morning about reactants, which I think is a fake thing. It's like a terminology that they use as like a blanket over a bunch of stuff. Things are still a little weird, aren't they? Wonder where those frames are going. This computer is a little bit jank at this point. It's a decent computer. It's just, there's a lot of stuff running on it right now. I guess Windows Update will kick everything off, and maybe we'll get a little bit of freedom. Like Stream Deck keeps freezing, which is odd. Usually that's relatively stable. But now that we know a little bit more about the schematic, I can start probing around at stuff and seeing what voltages are where and where we might find broken things within the circuit. The hell's somebody's idea of farming me? He's very still air for what he's talking about, but it's doable. All right, let's see here. Put that up as a generic Discord. We're still doing the synthesizer. I'm mad at it. It's not treating me very well. We haven't really done much, but that filter should absolutely 100% be working, assuming that we have replaced the right stuff. And I have a suspicion that some of those 2N3904s are what broke, even though those are jelly bean parts that should never break. Maybe some of those other transistors are dead. So we'll do a little diode testing transistors and stuff like that. It should be pretty by the book. We should be down to brass tacks and other colloquialisms that I can throw at this problem. What's up, Al Patro? What are you doing? What are you working on? It's so hot out right now. It's ridiculous. Oh, I gotta kick the fan. I have to kick the proverbial fan. What does that even mean? What is that? That's not a proverb. Nobody says that. Make sure that I have air on me, otherwise I'm gonna die. Willow got to go out before stream, and she got to play with all her friends and met a new dog. So she should be good until later, much later this afternoon. So if we need to go late, we'll go late. Hey, what's up, Walrus? Good to have you here. Glad to have you here. I had some commentary about Fallout 3 from what I was watching last night, but it's left me. I don't remember what I was going to say. Other than we were throwing about theories about Anchorage being kind of an attempt at Bethesda making a first-person shooter. Doing logic gates with transistors. Ah, that sounds complicated and very, very annoying. And also oddly relevant. Oh, my soda. Where's my soda? Oh, my God. Oh. I hate what's happened to sodas. You used to get a six-pack of these puppies, and they weren't these little thin, dainty. I feel like I have to lift my pinky in order to sippy out of this little. That's enough soda for me. I hate these things. We used to have big fucking bottles. I mean, we still do. It's just, they're putting these things up on the shelves. I was doing like a smash and grab grocery run. I should have gotten like two of these things. Two of the six packs. But the six pack was on a cardboard thing. So companies have been fucking lying about how environmental they are with the six pack holders. They could have been making them out of cardboard the whole time. But instead, we have microplastics in our balls. That's where we are. Share. This is all I have. This is the last one. I can't share. This is it. I'm starting to get the shakes. Microplastics are indeed stored in the balls as well as a lot of other places. What up, Madam? Yeah, we're still working on this thing. I just can't anymore. I read up about the transistor ladder filter and capacitors and reactance. Reactance is spells, but we're going to have to take a multimeter to this thing to test what's actually functioning. Yeah, microplastic preservatives. I've been taking microplastics in my pills. My ADHD medication has microsponges in it. So I'm probably full of microplastics, fucking up my endocrine system. Da-da-da-da-da. I've been on that drug for like 20 years. But at least I can get stuff done. I hate this thing. I'm trying to build a diode ladder circuit from a Hajiwo YouTube video, which is the same thing as this. It's funny that we should get caught on this, but it's this wonderful circuit topology that allows us to have these kinds of filters. It's a very nice sounding filter. Today we will triumph. I applaud your confidence, and I hope that I can one day be as confident. My confidence is shook. I stopped uploading for YouTube. I haven't gotten anything done. We're going around in circles with this thing. It's a whole cascade of things that are just falling apart around me. My house of cards is descending to the ground, to the dirt. But yeah, we will. I'm going to continue to poke the bear, and maybe we'll get some results out of this thing. Hopefully, I think at this point we can trace that circuit into the chip, and now we know what's going on around the chip, and so I can start to piece together where this all falls apart, because we've replaced the stage after it, and we've replaced the stage before it. So the problem is somewhere in here. It's 3 stages, really. It's the VCO. I mean, I think there's 4 stages to this one, but this VCO into the ladder filter, into VCA, and then some other like gate stuff that happens. But that's it. VCO, filter, VCA, power, other power for the filter. That's it. That's what this circuit is. Then we can actually do some other stuff. Oh, one other thing that I wanted to do was start another test print. The Benchy doesn't work on this printer. I think the flexible steel sheet that I'm using, because it's like people use those for 3D printing, they love them. It makes it so that you don't have to move the entire axis all over the place. You can just pluck off that sheet, and I'm still not good at that, so I'm getting resin everywhere when I do that. But you can pluck off that sheet and then throw it into an alcohol tank or whatever. That's all well and good, but it's not as sticky as the OG material, so something like this fails. It just fails. It just drops off because the surface area here of the base, the yellow part, is overcome by the whatever the hell that plastic is. I don't understand what the name of that. I can't memorize things. Anyway, it's like right about here is where it plucks off of the lifting axis, because that surface area is huge and it overcomes the other suction. So I could tilt Benchy on its side, or come up with some other kind of a weird, clever way to print it. I think maybe I just need to find something else to print, because enough with the Benchies. I need something that's going to look right. I guess I don't have to start soon up. Whoops. So what does one print first on a resin printer? There's like a text engine. Yes, I know drag and drop files. Can we get rid of that? Oh, I see. If you have Pro, you can just enter text directly. I could do an XYZ cube, but I know it's going to look perfect. Or I could do their logo. Or I could find something on Thingiverse. Let's find something on Thingiverse. On Thingiverse. I can't talk. I took Willow out to play, so she should be good for a while. Hey, Poopsie Doodle. Thingiverse.com. Let's find something stupid to print that won't take a year. I'm not printing the bow and arrow. Banana sword, banana katana. No. Though that is fun to say. drip irrigation system. That, as somebody who is currently in charge of a garden that wraps around the entire freaking house because people can't keep their wallets away at summertime and they go to the garden store and buy 10,000 plants that won't even last through the next season. I'm sitting out here with watering stuff, just grinding my teeth, going, this is sucks. What is going on here? A free or 3D printed drip irrigation system is something I'm thinking about. That's starting to take up a little bit of brain space for me. Siggy verse. I like to sing the verse. Gardens are awesome because gardens equal food. I see it the same way. I enjoy growing food. I really do. I should get like lettuce and stuff and be completely self-sustained by the end of summer. That would be the goal. Seeing as that grocery store trip that I did earlier this week was painful. That hurt me personally. But yeah, I absolutely would be the type of person to have an automated drip irrigation system with humidity sensors and soil sensors. The problem with it, soil sensors go bad. They go real bad. Unfortunately, the soil sensors oxidize and they stop working. But no, we gotta find something stupid to print. I'm not gonna print a knife. I'm not gonna print the trendy Jeep. TP4065 charger module mount. That's clever. I should share more of my stuff on Thingiverse, huh? Lego Skellington. That looks a little complicated. There's a lot of Fallout stuff lately. I saw one that was like the XO1 power armor that I was like, you know, I should probably try printing that out. Actually, I should probably print out something that I can crush as a strength test. Lord of the Hunt. Jesus Christ, this is what people do with resin printers? You just print out anime figurines. Ergonomic tweezers. That scraper was tempting, but that's too quick of a print. Robot hand. Instead of a robot face like Uo has, I could do a robot hand, and it would just flip everybody off. That was a joke. What was that a joke from? What was that from? That was from, like, the fake 303 that I can hit with a hammer. That's a really good idea. Oh, wait, but we can print out a titty princess. Titty princess. Why? Why is it accentuated like that? All right, anyway. different stuff. Let's say a car would be kind of cool. I need something that's not going to take a ton of time. I'm looking for something like a Benchy. Maybe we should just do like a resin test. That's disgusting. Let's see, resin test. Or something really stupid. I'm not gonna, oh! Is it a different, this is a titty merchant. Actually, there's far less titties on this one. I don't know what's going on here. What am I looking at? It's like a pair of human legs coming out of a skeleton. All right, get out of here. SLA resin funnel system. Actually, that could be very useful. Oh, I see it. It sits on a base. Yeah, for like hanging this. This is a problem that I have. I need to be able to hang that up. If it worked on a 2020 rail, I would be all about this. Because, yeah, something to hold that reservoir inverted so it can drip out properly. Resin printer torture test. Rubber baby buggy bumper. Let's do the torture test. Let's do it. Give me this one. Give me it for free. I don't share anything. Where's my directory? Here. Why not? It'll take 10 years to print, and then I've got a perverted statue. And I don't want a perverted statue to hang around here. I got a whole truckload of equipment just unloading in a parking lot. The garage door guys are 4 hours late. Put the headphones on to rip boards down and move scaffolding. Damn. You got your work cut out for you. Yeah, everybody's running on their own time, huh? Files? Resin print torture test. What happened? Oh, my computer was working too hard. I don't think this is the intent. I don't think that's exactly the way that they want you to print this. The problem is this surface is going to pull. I don't know if this is going to work. Maybe it will. How am I supposed to print it? Am I supposed to print it like that? On its side? All right. Thorough resin printer torture test that will test freestanding and embedded features as well as overhangs. This print will give a very good understanding of the printing limitations of your printer settings. This is a flagship Saturn III Ultra. It should be able to handle everything on this platen. We'll see. Don't want to leave $500,000 in new machines in the parking lot over the weekend. No, it's going to be a... Well, I don't know where you are. You could be on the surface of the sun or in Antarctica for all I know, but it's a scorcher this weekend. So yeah, I would feel bad leaving equipment outdoors. Any equipment, even my roofing tiles, I feel bad leaving outdoors. All right, so we print on its side, and this is going to take like 9 hours because that is a very tall thing. No. I've gotten Benchy to work with supports. That's the one that I was showing off. But I didn't get Benchy directly down on the bed, and I think it's because of that steel sheet. I think the steel sheet is too smooth. Even though it's been roughed up, it's got a little texture to it. I don't think it's sticking as well. It's Scorcher, I'll call now. What do you, huh? What? I don't get it. So yeah, let's just grip it and rip it. Let's just rip this one out. It's supposed to stick to the bed, given that surface area right there, which means up here is danger zone. That's going to get kind of dangerous. There's more theft than the sun. Oh, I see. You're not worried about ultraviolet as much as you are gremlins. How is this really going to peel off of that surface? This is going to be crazy. This is gonna fail. This is gonna fail, but I guess let's just give it a slice, huh? Oh, that's just where I highlighted it. Like, some of these geometries are real torture. Woo! That's a tough one. Let's just see. Does it... Oh, no, don't split. Wait, what are you doing? Oh, I see. This is just what you're viewing. I see. Depending on the location of this. Simulator, that's weird. It's going to make me want to buy Pro. It's got a 3D model of the printer. Oh, it's cute. That gives you a much better idea of the size of everything. Bump, bump, bump. That's cute. That's kind of cool. Wait, so is it as represented in the slicer? No, okay, yeah, the working area is the other side. Okay. All right, this flips it over for you. It just looked like... Okay, it is lifting out of the goo. Okay, I see now. Yes, it is meant to print in this orientation, although 180 degrees would probably be a good idea so we can actually... Well, we're not going to really be able to see it much because it's only going to be like a 1-inch window that we can see through. And it'll be more of a surprise like this. But yes, that's the whole challenge of it, is that it's supposed to print in this orientation so that you can see the limitations of your printer, is my understanding of what I read of this. Very thorough resin printer torture test will test freestanding and embedded features as well as overhangs. So in order to get the overhangs, you print it. Well, but that's an overhang. Are we sure that I'm supposed... Maybe I am supposed to lay that down flat. Because, like, the overhangs are over here. Internal features and overhangs. These are just, like, trough dimensions. Yeah, I think you're right. I think it does actually need to be... I think it needs to be popped down on its side. How do I do that in this program? Arrange, move, range all, rotate, On plate. There we go. That's what I'm looking for. You. Object has structural errors. I'm not trying to repair it. Bonk. There we go. Okay, so yeah, it is supposed to do this way. Bump, bump, burn it. Well, let's see what we get. That seems a little less torturous than what I expected. I printed very similar and flat on a Saturn 2 months ago. Okay, well, we'll try this. My hope is that this big plate doesn't pull off, because it seems like it might be of the amount of surface area that the bed has struggled with before. So we'll have to check in on it early on. I want to save my work. All right, let's give this a shot. I may have trouble with stuff sticking on this printer, and I'm not sure what I should do about that. I guess maybe clean off the plate and rough it up with a piece of sandpaper or something. Because Benchy kept unsticking. And now I'm out of soda. It's a sad day indeed. This will print a lot faster like this too. Uploading to printer. Cleaning process. All right. I prepped the printer earlier. I pulled out the failed print, and then I got rid, or pulled out the failed print and zeroed the axis again. Not with a piece of paper. I just set it back to 0. All right, so now that thing's just going to do its job. We can listen in, and maybe we'll hear a big, like, noise when it pops off of that plate. I wish we were playing video games, chat. It's gotten to the point where this thing feels like homework, which I guess is okay. I've trained to do homework. I'm used to the feeling. I've done more homework than most people have done as an engineering student. Turn down the music. Okay, the music slowly faded out. Hi, hello, hello, hi, hello, hi. Yeah, so welcome. What's that? Happy with the result. Interesting to see if you get small prints printed in the Saturn 3. I just started a test print on the Saturn 3. Benchy is giving me troubles. I think the steel sheet that I'm using isn't sticky enough, and so it's trying to pull it away from the plastic, the reservoir plastic, and it's just not able to. It just pops off. So we're gonna see if this one pops off. This one is a big square flat sheet, but it's got a lot of cool little features and like tiny things on it that we'll get to see what the efficacy of my 3D printer is. It's a Saturn 3 Ultra. We'll see. It has a good screen. I don't know what else it takes for a resin printer to be considered good or bad. I wonder what the class-leading resin printers have, like the ones you would find in like academia. Would they have like macadamias? I mean, would they have like super duper accurate reinforced axes that just don't move? Because this thing is pretty set for the type of stuff that it has. So we'll just have to see. Why is my social stream blade not giving me these messages? What's going on here? Something weird. One of them does, but I leveled it directly on the vat, no paper, nothing in between. I didn't do vat leveling. I did a piece of paper, but maybe that's the key. I already had a successful Benchy print. I've got a very nice looking Benchy. I'm gonna refresh this page. Maybe it's just timed out or something. Yeah, the leveling that I did was off of the vat, and I printed a perfectly fine Benchy. Maybe the surface area was enough from it being fully suspended. So I tilted it up, and then I suspended it completely on supports, and that made a very good Benchy. It's just that the bottom of the Benchy, the bottom of the hull, wasn't totally flat. Here it's right here. The bottom of the hull is a little wobbly, and you can't see the CT3D text because all the layers go diagonally through it. I guess it just, the supports kind of did weird stuff to it. So I don't know what would be required to make that flat other than just like sanding it down afterwards. I guess the reason people on resin printers do figurines a lot is because they've got that nice big surface area on the base, and then it tapers down from there. So whatever features come out really nice, and you've got all this big force to kind of pull it out of the resin. Yeah, so I've already got one successful Benchy. It is the cleanest Benchy that I've ever seen. It's not a torture test for a 3D printer, though. Benchy is very easy for resin printers. It's very easy for resin printers to create. So now we're doing a torture test. This is something we found on Thingiverse that'll help me take a look at how we do details and stuff like that. And maybe it'll give me more of an impression of what I can accomplish with this resin printer. In terms of like engineering, like stuff that we would do around here, the resin printer far excels any sort of detail level that I need. If I want to add like a really nice logo plate to something, I guess I could. But generally with the toothpaste thing shitting, the shidden toothpaste tube, like that type of printing, that's fine for us. I don't need all that much detail. I need strength. And PETG is strong enough that you can hoist your car up with it. So for that serves all of my purposes. Resin, as an aside, I guess would be kind of, we'll see how it is. I need to print up that thing where I can hang the reservoir too, so I can hang it over a filter, because I've got a filter funnel. If I can hang up the reservoir, I guess I can get some of my chemistry stuff out. Maybe I can do it just with chemistry stuff. That's a thought. All right, well, I'll think about doing that. I'll think about getting my chemistry stuff and putting it in the hood over there, because, yeah, we in the hood. We got a 3D printer over here. Look at it. Look at it. It's doing its thing, I think. I don't know. We'll check in on it later. How long is this print going to take? Let me just check the time over here. Oh, it's only going to take an hour. That's nice. So we'll be able to check in on it soon and see if it peeled off of the bed. And if it did, I got to reevaluate what that bed is. I don't know. How do you get stuff to stick when it's submerged in goo? You can't like put glue stick down. I'll have to figure it out. I don't think it's a leveling problem. But yeah, anyway, we're looking at this thing. What is this thing? It's this phallic looking circuit. So I love it. I love it. I love everything about it. We're looking at transistor ladder filters, specifically focused on the TB303 and its copied counterpart, the M303. So as I'm getting into modular synthesizers, I have Dave and Julian supplying me with stupid shit that they broke. So Dave had the M303 and got it in the mail and plugs it into his thing and it breaks. Or I think maybe he was reconfiguring his modular synthesizer and it broke. And what the M303 is particularly good at doing is breaking and acid house. It has a voltage controlled oscillator that makes a particular flavor of waves. It has a voltage controlled filter, which does a particular type of Moog cutoff. They developed this circuit. And then it has a voltage controlled amplifier, which is a fairly simple thing. You plug all those things together and you plug that into the rest of your modular synthesizer and you've got really cool sounding acid house sounds. There's a Moritz Klein video, of course, on everything. There's a Moritz Klein video on a diode ladder filter, and the music that he plays at the beginning of it is just tasty. It's very good music. It's food for the ears. I watched the Moritz Klein video with hopes of getting a little bit more of an understanding of this thing. When you plug it in wrong, it explodes. And when it explodes, it doesn't actually explode. I wish it did, like, fucking explode, because then this would be a little bit more familiar to me. but then Dave wouldn't have given it to me. He would be dead. But instead, Dave lived, and he gave me his synthesizer broken. Now, these blow up so often that the engineers at Acid Labs have a PDF that details what parts need to be replaced, which is just up my wheelhouse. And if I had just sat on my fucking hands until Ben Gizmo, a viewer, gave me a link to this PDF and I replaced specifically the parts that were broken, we would be fine. And I would have a working M303 sitting in front of me. But I'm dumb. I'm too smart for my own good. I know how to do this stuff with electronics to the point where I broke it further. This can happen, and it does happen. It's just going to live in my head for a little while. I plugged this thing in, and because the two headers on it are symmetrical and spaced just right, you can plug it in upside down. There's two PCBs that fit together with pin headers, right? And the pin headers are just symmetrical enough that you can flip it 180 degrees and they still plug in, which is really, really dumb. And I did that. And so things got hot. And I don't know what things got hot because you can't see the circuit when the two pin headers are plugged into each other, which is why, having broken more stuff, I decided to dive fully in. And we desoldered the pin headers and we put them on backwards. And what that allows us to do is to run insulation displacement cables, IDC cables, from one end to the other. See, the frustrating thing with IDC cables is that you can't flip them to the other side in order to reverse the orientation of the pins. And if I flipped it 180 degrees, it just wouldn't, that just wouldn't work. So your pin 1 is on this stripe, but you would have to have like an alternative IDC that flips pin 1 and 2 because we're flipped in the way we're plugging it in. It's a weird spatial acuity problem. So very, very annoyingly, and this is a common procedure to do, I had to desolder two row headers. What you do is at least use ICUP. Cup. All right, so these, a way to do these two row headers is you can get a big piece of copper wire and put it right in the middle. Just add a bunch of solder and get your big, gnarliest, veiny soldering iron and hit it up so that everything becomes molten at once. And then if you plug an IDC cable into the pin header, you can pull it all out as one big thing. Another way to do them when they get particularly frustrating is to just pluck one pin at a time. So you heat it up and you pull the other side. You got to be careful though, because with these orphaned vias, there's a tendency when you're using a lot of heat and a lot of force that everything isn't molten at the same time, and you end up pulling away at that top layer, and then you're at the mercy of whatever bonding there is between copper and fiberglass. The silk screen isn't there to help you because it's in a keep out area that gets solder, so there's nothing holding that via down. If it's an orphaned via, like if there's nothing around that pad on the top layer, it can pull off very easily, but maybe it doesn't matter because nothing's connected up there. But if you have one trace coming in, it might not hold down that via very well, that pad, I should say. The via is I think the internal part's a sleeve that's sometimes electroplated on. Anyway, either way, you got to be careful with these things because you got to make sure that your heat gets all the way in there before operating on it. I used what's called Chip Quick, which is an easy way to spend a lot of money to do nothing. Chip Quick is a wonderful substance. There's a particular type of metal, I forget what it is, but people sometimes make their own Chip Quick because Chip Quick is horrifically expensive. But what it does is it's got a much lower melting point than solder. So if you alloy it with solder, if you add a little bit in there and trace it around, it'll stay molten much longer. And with surface mount parts, it's shocking. You're like, I'll add a little bit of Chip Quick, and then when I get over to the other row of headers, I'll then heat them all up quickly, and then your part falls off. And you're like, what the it just jettisons from your circuit. It's amazing stuff if you can afford it. But we've had troubles with the synthesizer. We've replaced a lot of stuff. I got it into this configuration, and we're now finally able to actually trace around the board. Now, we replaced the components that are the commonly exploding components when you plug power in wrong, right? That didn't fix it. There's no output. So we started tracing around and looking at the origin of the VCO signal. You see, what happens is a frequency comes in and it hits this sort of junction of transistors that are matched, and it excites one and the other in sort of a reciprocating manner. And that creates our audio waves. And the audio waves are then processed into a square wave and a triangle wave. So we got a square and a triangle. I don't think there's a sine wave anywhere on here, but that is one tactic for making a sine wave. So we found that wave, and we traced that wave. And by the way, in the midst of doing this, we've taken a couple streams to understand and know what the layout is here. And one of the ways that I'm doing it that I see a couple people in chat who said, wow, I've never thought of doing that. Well, yeah, multi-layer image processing is a thing. And if you're lucky, your multi-layer image processor doesn't steal all of your work and dump it into an AI. However, yeah, so I have tons of money, so I don't buy GIMP. I use GIMP It is a very embarrassing name on a decently capable piece of software that I'm able to do all of my photo editing, image editing on. That's how I do all the thumbnails for, you know, the stream and stuff like that. You get layers, you get some tools. It's a little bit like Photoshop, but not in enough ways that you know what you're doing. Actually, Photoshop has changed. I don't think I would be able to use it as well anymore. I use like old versions of those programs. But anyway, so I use GIMP. It's free, and it works pretty well for what I need it to do. And what I needed to do is to overlay both sides of the circuit board and give me a scratch pad. So we took a bunch of pictures with the camera in exactly the same orientation. I used the microscope because it's nice and fixed and everything like that. And I slid the board around and we got all of the pictures and we composited them together. It doesn't have to be perfect. There can be weird seams on your base images. But what happens is they roughly overlay over one another to give us the ability to look through the board and to see where all of these little dots are going. Those little dots are called vias. They carry a signal from one side of the board to the other, and then the lines are known as traces because they trace along the board and they conduct signals from place to place to place to place to place, right? So we looked at the traces, we looked at the components, and I highlighted them by drawing over them in this software. So I just used the mouse and I did janky lines and I did a small enough thing. They don't need to be perfect. All they need to do is point from place to place. Now, sometimes when we were working on stuff like the IEDs, wait, that's another frozen. What the hell is going on with these things? Hold on one sec. Let me just refresh my overlay so that you guys are actually up on screen. Properties, fresh. There, that'll work now. Anyway, so what we would do is actually get these images into CAD, and I think that what do you call it? Fusion 360. I think I could probably do it in Fusion 360. I probably could do the method where you import the board layers into the program, and then you would use the CAD circuit layout tools in order to put together all of these connections, and then take all those connections and clean them up and clean them up and clean them up until you have an actual representation of the entire circuit. I probably could do that. The problem with doing it in like Eagle and Fusion 360 is that you have to have all of your hardware in there, and that just seemed like kind of intimidating. I didn't want to get all of my hardware into Fusion 360, especially given that there's some parts that we don't know the identity of. We didn't know actually quite a few of the components that are on here. Turns out people at Acid Labs did us a dirty. They did us a very bad. They did the anti-Lewis Rossman. They went through and they sanded off the identity of some of the chips. Now, for one of the particular chips, this one here, it was pretty difficult for us to figure out because you know, well, without the circuit layout, we don't know what we're doing, right? We don't know what it could possibly be. So actually, a member of chat overlaid them and had it fade back and forth between the sanded part and the one we suspected it being. We basically looked at the sanded markings, messed with the color settings of GIMP in order to bring out the former text. They didn't sand it enough. That happens a lot. With another particular chip, we didn't know what it was up. This is actually the one that we're working on right now. This one, we don't know what it is, but we do know that our wave goes into this chip and then comes out of what's called a ladder filter, a diode or transistor ladder filter, basically using transistors and diodes as a type of voltage controlled resistor. And you can make a pretty decent filter with it. This structure is unique and easy to find, and yeah, we were able to just knock that down and say, hey, oh, that's what that is. So I just did a little bit of reverse engineering yesterday to figure out what specifically parts of the circuit look like in a schematic. We don't have a schematic. We have a schematic of the TB303, which is what Acid Labs made their module like. So it's very similar, very, very, very similar. Yeah, there's a lot of acronyms. There's a lot of acronyms. This is the VCF, the voltage controlled filter. Moritz Klein does a very good video on the diode ladder filter. There's also, I found an All About Circuits a couple articles on All About Circuits that explain it, but it uses this magic called reactance that I think is like 7 things that are they put a blanket over so that they can sound smart. They can say, oh yes, reactance. It's the change in transmissibility of the capacitor depending on the frequencies that it's getting. So you have a different reactance for different frequencies, and that's I don't know anything deeper than that, and I would like to learn it a little deeper than that without having to go through equations. I'm sure there's a nice, easier way to look this up and explain it, but everybody wants to listen to their own farts, so they start explaining things in these incredibly complicated ways. What's happening here is our wave comes in to the diode penis filter, and a slightly differenter wave is created on the other end. So we get our regular wave and we offset it up, and then we get our slightly differenter wave and we offset it down. But we've got to be careful that when things equal 0, it doesn't do a circuit and overload something, right? Yeah, it's our diode penis filter. Look at it. You know, that's what I'm calling them now. Ladder be damned. That's a penis. I know one when I see one. So in the penis filter, we have our stages of filtration. At the bottom here, we have the thing that's making the 2 variable signals. And at the top, we have our source. Or sorry, our, what is that called? Whatever. Trying to direct 2 people in languages I don't speak. I got a call from somebody that was speaking, I want to say Chinese, but I didn't get enough words out of the guy. Like, I got several phone calls from somebody with my area code number, but didn't speak my language. What's up, uncle? Is this the penis filter? Yeah, this is what's making all those poink, blonk, beat, boy noises in penis music. If you guys don't know penis music, live your life. Just live your life. Just keep living your life. Don't think beyond this. You're fine. Just live your life. Don't look up penis music. Anyway, so yeah, we've gotten to this filter. I had an idea of what some of the structures here were. There's stages of the filtration, and then an input and an output stage, basically, is what it's made up of. And you can only have an odd number of these things because you want to be, what was it, sourcing in the middle? I don't know, man. I'm just barely familiar with it at this point. But what happens is you have this differential signal, and you take it out of this stage up here, right below. Basically, you're what is this one doing again? I forget. You're like pulling something down, and I don't know, things happen. But anyway, it's in reference to these voltages coming out of that, I think. And so it comes back here into some type of differential amplifier. And I guess in this case, we're using transistors instead of... Could I stop hiccuping for 1 second? In this case, we're using transistors instead of an op-amp. I don't know why they would do that. Space, cost, whatever reason. Moritz Klein, on his input stage, uses an op-amp. Uses 3 op-amps, actually, which is an excessive amount of op-amps. And I guess Moog decided that they would do it, this way. Moritz Klein's, or no, the one in all circuits. This is all in the streaming project section if you want to buck up on this stuff. I would suggest not, because it's a whole bunch of nerd shit that you don't need to know. But yeah, all circuits bridges the 2 bases of the transistor, whereas Moog does the transistor into the collector, turning it into a diode. This is an important thing, but diode testing of a transistor. We're going to be doing this today because this is where we're at. This is where our life has gone. With a transistor, you have 3 layers of silicon. You have an NP and an N, or a PN and a P. And in this circuit, you just have a PP. But actually, if these were if these were PNPs, I could call this my PP filter, because it would be the P and then the P at the bottom. Pinocchio. Here you go. How to test a transistor as a diode. A diode is a P and an N junction. It's one single silicon junction, whereas a transistor is a PNP, and if you excite the middle, then it flows out, right? It's the water comparison is a little reductive because these don't switch instantly. They don't switch instantly. And so we're taking advantage of that and making it work like a resistor, voltage controlled resistor. And in this case, we have a bunch of transistors with the collectors and the bases connected, but we can actually test these, the PN junctions, and figure out whether or not the transistors are broken. And so that will lead us into being able to figure out what went wrong, because the transistors are the most sensitive part of this circuit. I mean, they're most of everything of the circuit, but things like capacitors and resistors, we can directly test those with the multimeter, and if they don't look blowed up, they're probably not blowed up. I mean, there's a possibility that there would be like a bad solder joint somewhere, but those transistors are the sensitive things. Those are the ones that will break. So those we can definitely check out, and we got a lot of them to look at. I also need to make sure that these are wired in the way that I think they are, and actually we have a layer for that. Where'd that go? No, there it is. These are, yeah, okay, so these are indeed wired the way that we thought they were. They are wired as the Moog type of transistor ladder, not some of the other ones that I've run across. I tried to research this during my morning and you know, take care of the dog and do all that stuff all at once, so bear with me if my knowledge sucks. If somebody can explain to me what reactance is beyond what I've explained, maybe in a way that makes sense in terms of the physics, I would love to hear it. I was going to put that in the title, but there's a lot of people who like sniffing their own farts that join in on the stream, so I'm a little reluctant to play into that. Because they're when you get somebody that really likes the smell of their own farts explaining to you electronic stuff, they explain it for them and not for you, and it ends up being a wildly overcomplicated explanation. I try to keep it humble. I'm looking for a window. What am I looking for? Oh yeah, I wanted to Discord into Dixord and then open up my stream project, because this, we have a all about circuits as analyzing the Moog filter, and they kind of gush about how unique and interesting the Moog filter is, and they talk about reactance a whole lot, but they try to reduce the circuit in terms of like elements and analysis blocks that can be gone through a little bit more easily. It's a fairly complicated filter, and you just don't, like, they don't teach you this stuff. It's a really interesting thing that they've done. They've sort of gone off and discovered a way to arrange a circuit in a unique way. Okay, I'm up to date with my messages. But yeah, they describe it in terms of input and feedback, and I don't know if that's quite the right way to describe it. And they bridge all of these. I don't know what the difference is between the two. What does that do? Maybe at some point, you know, we tried to breadboard one of these mofos and it didn't work, and it's mostly down to my inability to breadboard with these stupid 1% resistors that I bought. I bought these 1% resistors, and they are, you know, the margins on them have to be tiny, so there's not a lot of metal on them. They had very thin leads, and those thin leads do not agree with my solderless breadboard. So we would have had a platform where we could test this shit, but we don't. Maybe we'll circle back on that. This has taken up too much time and resource in my stream, and I have other stuff that I need to be doing that I have not done. So why are those fans still on? I guess the fans stay on permanently on the 3D printer. What is the status of the 3D printer? Let's check on that. 65%. I need a node, geniuses in chat, I need a Node-RED node that will monitor the various printers in here, because I want to have an alert system, like a universal alert system with like colored lights, or maybe one of my VFD screens wirelessly. I could put like a big Staples Easy button next to it, and so I punch the button and it'll tell me any alerts that are going on in the shop. I can do all that in Node-RED. I would like to unify a lot of this stuff, and then, you know, like channel points can do interesting things around the shop. We will get to working on that very soon. I had to refamiliarize myself with Node, and then we've got to take the channel, all of the channel stuff into Node-RED. All the OBS stuff is already in Node-RED. I could do almost anything in OBS. So, I mean, like, I could have channel points that switch scenes. You know, catch me with my pants down. Maybe I could put a camera upstairs and have a check on Willow camera. And have that be locked behind channel points. Where's the fart button? That is the natural thing that comes out of the rest of this, is that the fart button will come back on Wii. No, I mean in Force. I have no idea how this thing works. And they tried their best to explain it. It can be broken up into a driver, a low-pass filter, and... Huh? Wait. Oh, B and C are they're both low-pass filters, apparently. But this would be, the current comes into the bottom here and controls something, the cutoff point, I don't know. But then why, if it's just current coming through there, why is it so goddamn complicated? What is all of... Where did my stuff go? I have so many pages open right now. This is what happens when you do hardcore circuit analysis. Actually, the stuff on the website, that stuff on the internet thingy was way more hardcore when you're actually going through equations and stuff. We're going through complicated circuits. The Society of Fart Smellers paged me and let me know you needed an explanation. Yes. Can you explain to me, like, in the physics, what is reactance? Because from what I'm seeing, it's several things that they kind of put a blanket over. And they just said, that's reactance. I haven't gotten a pretty good explanation of it. Hey, Mahalo. And hello, Wexo. Hold on, I'm trying to... Which windows do I need up? Yeah, those are the ones I need up. There's the print that we're doing. We're doing a torture test. And then my 303 schematic. There it is. It's on the schematics page. So this is the penis ladder filter, diode penis filter, the diode ladder, transistor ladder filter of penis, of Moog. This is the Moog transistor ladder filter. There we go. I got it out. Our source is coming in through this 220K. It's the obvious line that goes straight down. And then it goes into the common, I guess, penis ladder filter kind of stuff here. But this is supposed to be like feedback. And then down here, we have some kind of a control circuit. And I would assume that part of this control circuit is mixing in control voltage so that it can do something with current. But I don't understand why it's so... Look at how complicated that is. And we're also injecting a 5.2 volt signal in here to, I guess, offset one of them from the other. The sum of resistances from inductance and capacitive components as applied to an AC signal. That feels cut and paste. So is the sum of resistances from inductances and capacitive components. So you have resistive elements due to things like frequencies and minor inductances that turn into I gotta get out like a textbook and just start like really processing what's going on. I tend to like gloss over stuff I don't understand and think that I've read it. It is frequency dependent. Is it because the physical properties of the capacitor allow certain frequencies better than others, aside from the phase shift that it would impart? It's like I know what words to say, but it's not clicking. Yeah, so this right here is how it's being controlled. The input signal goes into here, and then what we should see up here depends on, I guess, the voltages coming in here. We know 5.2 volts works. We know our signal coming in theoretically is within range. And it is very similar to the OG Moog. We have an offset square wave that's got a lump in it. We have a sawtooth that is a little bit less sharp. It's not as sharp. The saw blades aren't going to cut as well. That is also offset. See, this is offset by 5.5, and this one's offset by 5, which makes that 5.2 volts very interesting. So that 5.2 volts is throwing it back up to the offset, because C17, that input capacitor, should defeat any of it. It's going to bring us back to zero. just like Captain Planet. A dumb reference. I need to get a haircut. I'm looking at it. It doesn't look as coiffed as it used to be. That means I go get to meet the barber's dog again. She's a very cute dog. Okay, so we need to figure out where these various pieces of this circuit are, and we need to look at it a little bit more closely. This is what we got in terms of a little bit of the schematic, and it is looking very familiar. This is the LM13700, which I think was another Ben Gizmo thing. He was like, I'm just familiar with this stuff. And it's like, how? How are you able to name that ASIC? Apparently, it's one of the very few voltage-controlled amplifier for this type of stuff. It's one of the very few chips. And actually, the article, the All About Circuits article, talks about it. It mentions it in a list of about a handful of synthesizer chips that people use. Apparently, there's only about a handful. We got a center tap on that. Oh yeah, that's the same as it is here. And then yeah, we confirmed that these are wired up in this particular way. That's not connected. It just looks a little weird. So I want to see what's happening at pin 3. I want to see what's happening at pin 2, because apparently nothing is happening after that capacitor. So we can test on one side of a 2.2K, which would be right over there. It's right there. And then we've got that 1K, which is this, with 5.2 volts on the other side of it. So let's take a look. That's all we got. That's all we got. So before plugging this in, I have to be careful because my power supply does not let you cut power before sending it out. You can't adjust without having power on. It just says output off. I can't do anything about it. I can hit plus 25. I can hit minus 25. Doesn't let me do anything. It just makes clicking noises. It's one of the foibles of the Agilent E36 whatever. This is a really nice power supply, though. I really, really like it a lot. It is kind of obsolete, though. You can get better stuff out there, I'm sure. So we turn power on now that I've unplugged this circuit. Nothing explodes because I'm not Uwo's lab. I can't risk my fucking face all the time. I turned plus 12 up to 12. That was a very cool stream that he did, and I'm super happy that, like, he somehow had a friend who sourced about 1 billion capacitors and got all of these capacitors from his friend. And so he had a stream where he was wiring up banks of capacitors and soldering them together in like a minute per bank and throwing them on a dual rail thing in order to make a rail gun. I didn't like that he introduced the BB at a very steep angle. It should have been a very low angle so that it would naturally want to roll forward, because then it would be able to get that contact and take advantage of the Lorentz force that's being created. I was in chat. I did not exactly have the opportunity to sit down and explain to him that it was in fact Lorentz force that you're trying to take advantage of, because your circuit is the loop that's created by your projectile. And so the projectile has what is it? It has a direction of current, it has a magnetic field direction around it, and then that creates a Lorentz force. I'm getting this all confused though. Hey, what's up, NeatoCat? How you doing? But yeah, it's the Lorentz force that's flicking your object forward. I think he just turned him into plasma though, with a giant discharge, which is not something that I normally would like to talk about on stream. Okay, so we got plus 12, minus 12 all set up. I'm going to turn off power, and I'm going to plug in my device, and I'm going to double check that I'm doing this properly. I don't want to mess up my synthesizer, and this thing is a known bastard when it comes to powering up. So what you're supposed to do is you're supposed to take their little IDC cable that can be plugged in anywhere on the line of pins. It has these little divots on either side for extra pins to fit in. Evil cable. Why would this exist? I hate this cable so much. The mere existence of this cable is obnoxious to me. Look, I'll give you guys a close-up. This cable is an accident waiting to happen. It has divots on either side, what allow you to plug this in to an IDE header in any position. You can have it racked to the right, racked to the left. This existing anywhere outside of maybe a purely research operation is just abhorrent. And so Acid Labs decides to give you one of these. So we are on our own. We're in the Wild West. We know that this stripe represents negative 12 volts. So come back over here. Oops, hi. And I look at my cable. I'm going to go ahead and look up how to plug this thing in just so that we have verification of me doing things right. Because I think we go down here to the smiley face, and that's our negative 12 at the bottom. I love accidents as long as they happen to others. This synthesizer has been through enough. It does not need any more strife. All right, so that's plugged into power in the way that I remember it's supposed to be. Get this back onto the board holder that Wexo sent in. Actually being useful. And then I'm going over to double check M303 power plug. If I look that up, I should get a bunch of wall wart. What the? What? Huh? See, here's how it's meant to be plugged in: is with that big header doubles as a daisy chain style power setup in their particular product lineup. .3D printable board holders. Yeah, there's some good ones out there, but I don't know which ones. Something heavy. You want weight. So if somebody's suggesting you go get some metal rods and put it in there, like that'd be the good one. You want that weight so that you don't have to lock it down and you can spin it around and throw it in the air and all that stuff. But when you go to solder it, when you go to push on it lightly, it stays in place. Oh, it sounds like the 3D printer just finished. We'll take a look in just a minute. Why am I not getting anything? That's like a your synthesizer is still alive. Send the money to. Okay, so yeah, I did plug it in the right way with the smiley face. I don't use PLA. Blimeys, thank you for subbing with a Prime. I use PETG, and almost exclusively the PLA that I've used has probably been Polymaker. I'm not really sure, but the thing about with the prints that I do, most of the time are required to be a little bit stronger than PLA can handle in the size of the things that I like to build. So I do PETG, no smell, no fuss, no nothing. I can print directly onto my bed and get it directly off of my bed, not have to do any cleaning, not have to use any what do you call those? Disposable anythings. It's just plastic on bed, that's it. No extra stuff. But thank you, Blimeys, for the Primies. I appreciate it. PLA and PETG are kind of eerily similar to each other. Allegedly, there just aren't many raw pellet suppliers. Really? Huh. Oh, you mean all of them are Oh, I'm sorry. I misinterpreted. Yeah, no, sorry. All the PLAs are eerily similar to each other. Yeah, PETG are all different. They get kind of moody, and some of them like moisture a lot more than others do. All right, so I'm either going to find a square at the bottom of the reservoir, or I am going to find... Oh my God, step into the light. What's going on here? I just flashbanged chat. Are you all there? You're all there. Okay. You're still alive. Hail, traveler. So you're awake. Okay. You guys got flashbanged. Sorry. Let's just check this printer over here. I was gonna do a lab cleanup stream today, but I didn't have it in me. Ooh, crunchy knees. That's always nice. I gotta get like a pillow to put over here. All right, I'm gonna put on gloves for this just because this is a shit operation and it's gonna get stuff everywhere. The silicon mat I'm sitting on should be in here. Somebody called these sex gloves, and I don't like that. I like the black gloves, not as like a sex thing. I just like them. They don't show all the bullshit that you've been touching all day. I use them to work on my car. Why does everything got to be a sex thing? All right, what do we got on the bed? Oh, I see a print. I actually see a print. Oh, happy day. Put that on dim mode. Is that going to overwhelm you guys? No, that's pretty good. I can't read chat. I'll come back to you guys in a minute. I can't see chat. All right, print done, and then we move Z way up. Oh, cancel that. Manual, 50 millimeters up. I need to be pretty high up. Actually, that's pretty good. Okay, so that's high enough. I got to get a motion activated lamp. That's one thing I still need to buy. I did get that motor though, that the one user was like super duper adamant about me getting. So I have this. I'll have to make it work. And actually, if I do like a plug strip inside of here, I could use the Tasmota stuff and make Node Red control it all. I know it's very complicated, but it's fun. Okay, so I need to put this thing on there without dripping all over the place. So, 2 hands, you're ready. That. And then, this. Oh shit, this is broken, never mind. Oh, okay. What the fuck, when did that happen? When did that happen? I'm sitting here talking about how awesome PETG is. And this is just like, what the fuck? This thing is dead as shit. What the hell? Well, now I gotta spool up the other printer and print this thing again. Shit. All right. Well, that means I guess that I'm just jettisoning this thing into the alcohol. Lies in the Vaseline we are. All right, so this gets thrown into the alcohol bath directly. I wanted to drip for a while because it's good to kind of keep your stuff, you know? Pretty good. I just got to drip on my stuff. Fuck! Okay, I blew it up. Well, the rest of it goes in. There's a lesson. There's a life lesson. I blew up the print by being a little bit aggressive with my spackle knife. Oh yeah, back to 0 for the printer. I got resin on my biteable flashlight. Wonder how silicon rubber reacts to resin. I better not taste resin the next time I put this fucking thing in my mouth. I've got other rubber pieces that I can put on this. All right, so much for gloves. That thing's back at 0. All the little structures seem to be there, though. It looks like it did a pretty good job. Ugh! Come back over to you guys and see what chat's been saying. Hey, what's up, Gonad? How you doing? My eyes! I gave you guys a flashbang emote, and nobody decided to use it. Why is the printer in a grow tent? Resin and PETG don't mix. It makes it brittle. Oh, then maybe that's what it is. Oh, that's weird. Do I need to print that thing in resin? Great for choking. You're talking about the gloves? Why is everything got to be weird? Get this guy a headband light. Bite light's fine. Bite light is great. Bite light does a lot of stuff for me. I keep it in my pocket. And, you know, like if you have to pick up poop in the middle of the night, I have a dog. It happens. Always attach magnets to the bottom. Yeah, I guess you could do that. Dexter gloves. Why is that? Why is it a sex thing? Let's see. I recently made the experience that Loctite and PETG don't mix either. Huh. I haven't tried Loctite. The original meow. Yeah, it's fine. It's all fine. We've moved on to resin printing. Yeah, I bought a broken resin printer because I thought it was like perfect for this stream, right? Is why spend $550 or whatever on a super nice resin printer, and you put it on your desk and you go, I can print anything, and you just go ahead with it. That's boring. So what I did is got drunk and went on eBay, and I found a seller who sells broken printers under the premise that you get 2 printers and you can swap around the parts and you can make one working printer for a couple hundred less than the original printer's cost. I got 1. I didn't get 2, I got 1, and I said, hey, I'm Streamer Boy. I would love to try to fix one of these on my stream here. And so I think they sent me one that was in very, very good shape indeed. It said that the UV element was flickering, but it really didn't seem to be. And we took apart the whole thing, and it looks like it looks like somebody like pushed it or like dropped it or something. Yes, I know Dexter the series, and they did a real crappy job of wrapping that one up. But the printer had just a whole bunch of like mess all over it, and so I cleaned it up, got it working, printed a benchy, and then getting it into the tent, I tilted it backwards and spilled resin all over it. So resin was all inside of it and all around it. So it took 2 days of breaking the printer apart and taking Q-tips and all that stuff in order to clean every single facet of it. And in doing so, I got resin in my mouth. Most of these resin printer people are like, yes, I wear 2 pairs of gloves and an apron, and then I put on a silly hat and a face mask, and I have my special filtration fan in order to work with this stuff, and I keep it in a bunker underground where no human can come in contact with it. And others are like, I got 6 printers in this room and I don't smell anything, and I'm like, I got resin in my mouth. It's not that toxic in reality. Everyone you talk to will tell you that my head's going to explode on contact with it. Now, that's not to say that I'm not cavalier about being around the chemicals, because they're pretty bad. But the clear stuff that I got, not all that stinky. There's not that much of a smell. I mean, if I have the fan off and it's sitting down here all day, I come downstairs, I can smell it a little bit, but order it from a company that does it, then it's somebody else's problem to avoid the slime. Yeah, I just didn't feel like spending that. You know, I print weird stuff. I print very weird stuff, so. It can cause allergies to develop if exposed over a long period of time. I saw a big thing about somebody who spilled a bunch on their lap, and they had to like go to the hospital, and they were getting like welts and stuff. That's a little weird. And the fact that it causes an allergy, that's also kind of crazy. But yeah, I'm going to be careful around it. It's just, I had a couple little accidents early on. The only reason I got resin in my mouth is because it got under my thumbnail, and then I bit off my thumbnail, and I was like, something tastes wrong. Actually, I did it a couple times, but whatever. All right, so the print was semi-successful. I'm going to let it sit for a little bit in the alcohol, and then I'll swish it around and get it out of there. Open the door. Let me out of here. I'm gonna get it out of there. There's not sun right now, but there should be, because it's a super hot day. I think it's also very cloudy out there. No, there's plenty of sun. All right. I don't know if that windowsill will get sun, if I'll put it up in the windowsill or what. Allergic reactions? Well, I think it's fine. Look, a little bit of accidental exposure from under a thumbnail. All right, so that print is coming along. We'll see how that all tests out. It did explode because I took the spackle knife to it a little bit too aggressively. Oops. I'll be careful about that in the future. Resin tasting stream. Well, no, but then everybody will think it's like a pot stream. Everybody will think I'm talking about that kind of resin, which would be, it sounds like something I'd watch, but no, they would misconstrue instead of it being a horrifying implication. Okay, I don't have any on my hands. I was worried about that. It's possible that I have some in my arm. I think I'm good. We're looking at this complicated beast. It is a series of transistors. Lucky for us, a transistor looks like 2 diodes. It looks like 2 bears high-five. It does actually look like 2 diodes high-fiving. What up, Squirrel Brain? How's it going? We just got a test print off of the resin printer. It is sitting in alcohol right now, and I'm hoping to see how it performs with this stuff. Squirrel Brain is quite a skilled 3D printer designer. There's some really cool. I really love the look of a lot of those projects. Okay, so does Oh Bother taste soldering rosin? Is that a resin too? Filtered pine. I don't want to taste flux because that stuff is even more evil than UV resin. It is incredibly evil stuff. I never want to know the taste of that. Toke the Oak. Showing up behind violin stores with the tweaks. We can test this on our multimeter, and we can test to see if there's a 0.7 volt drop. The flux is ROHS. Yeah, ROHS is the reason why you're able and encouraged, in fact, to eat every single thing involved in electronics. So yeah, anyway, just to recap, NPN makes up a transistor. We can test the transistors in the circuit by testing if they're shorts or open circuits with the diode tester to see whether or not, you know, they have the properties of a diode. If they have the properties of a broken diode, then we know that that part of the circuit is broken. What's happening right now, what I'm testing right now, we are down here with this chip. Well, down here, we're in the smack dab in the middle of the circuit with this chip. So this chip right here, we have our squiggly wibbly wave coming in from over here, going down, jumping over stuff, going through big resistor-ish, and then big capacitor. And big capacitor is supposed to turn it into a wave that is centered on zero. Does it matter what direction you put it in there? Because it is an AC wave coming in, but it has a positive DC offset. So why are we putting it through the butt of the capacitor instead of going plus to minus? That's a little strange to me. Trackball mouse to save your forearm. Man, trackball mouse people are insufferable. They never stop talking about their trackball mouse. Halogen compounds. Okay, let's see. I need to get some of the noise off of here. So without the noise, we have already figured out what this part of the circuit looks like, and it looks like the penis ladder filter, which is the M303's penis du resistance, which is this circuit here. So this is the ladder filter. It's using these as, I guess, stages of a low-pass filter that are voltage controlled. See? They're so much nicer to use. Yeah, you're playing right into it. I played you like a fiddle. You played right into my hand. And I guess what we're supposed to get on the outset of this filter is this kind of a wibbling wave, this kind of wobbly nonsense. We need a couple things to make this circuit work. Right now, it is producing a wave based on 0 volts going into it. If we want to induce voltage, I have a setup for that, but I don't think we need to at the moment. When we do induce voltages into it, I need to tune it because we replaced a bunch of the chips. That means I need to get it back into 1 volt per octave tune. That's kind of an important thing. My friends are the musicians. They will yell at me if their stuff works weird. So, all right. So we need to find some of the signal traces here, and we need to find our wave. So what I'm do, and I guess we don't need this. We don't need this overlay. Let me turn that one off. Where is that one? Okay, so I bought a new oscilloscope. I spent more money than I think any of you should spend on an oscilloscope. Spent $700 on this to get a professional oscilloscope. It's a gift to myself for reaching an advanced age. Cool thing about this scope, aside from all of its advanced capabilities, is how quickly this thing turns on. Watch this. Ready? There it is. Isn't that amazing? And I'm already ready to work. Perfect. Oh yeah, it does all kinds of self-tests on boot. I just don't know why it takes that freaking long. Ridiculous. I look, my friends wear their watch like here because when you're holding a gun, you can check the time. Stupid. I'm pantomiming wearing a watch. I'm not actually wearing one. Okay, so start simple. I would put a monitor on the output, but I don't think that's going to be useful. Let's start with channel 1, and we're going to put one of the BNC to 1/4 or 1/8 inch stereo, 3.5 millimeter, I don't know, whatever. One of the headphone to mono thingy wingy. I'm going to put that on channel 2 just solely for the purpose of getting a ground signal. Because these all share grounds. You know what? No, I'm not. I'm not going to do that. I will hook up to ground individually. There should be a jumper around here. Yeah, there we go. Get a jumper to ground. That'll be slightly cleaner than going all the way through my oscilloscope. So I have here a probe that is grounded. And we have an image on the screen of the scope. Could OBS not put a dotted line in front of... All right, so now I can probe around and you guys can see stuff in real time as per what I'm poking. Scope, a microscope view would probably be pretty good too, but I think it would take up too much space. So we'll just go real close in with the Brio. Okay, so negative 12 volts. I haven't turned on the power. Good. All right, test number 1. Turn on the power. Nothing's heating up. More than normal. Negative 12. Okay, so I need to adjust this, and I'll turn off all the other channels too while we're at it. We had all channels like thumping last time, but all right, so this is up to 15 volts at its maximum. So what I can do is test negative 12, boom, ground, 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 positive 12. So we're all juiced up. I'm going to take this back down to 6 volts because it'll give us a little bit more resolution as to what we're doing. Yeah, like I said, the other features of the scope are actually kind of amazing. And it's touchscreen. Recently went on Mouse and bought a bunch of 3.5 millimeter jacks to make my own patch cables. It's fun to see the internals of all of them and compare. That's kind of neat. That's a lot of work, though. Okay, down here is where we create our wave, and its first output of the wave goes where? Let me get my GIMP. Let me go ask the GIMP. Hold on. Our signal goes... where does that go? Those are the adjustments there. I see. So it goes all the way over to... oh, there's a lot of stuff there. This header. And we should pick up on it here. And there it is, an offset square wave. So just like in the simulations, no, just like in the manual, this is a 5.2 volt offset, at least for this wave. And then if I jump over to this pin, nothing. Wait, hold on. Oh, that was the center pin, wasn't it? This one should be a triangle. Yep, there's our triangle. Except the triangle is centered on 0. What is that all about? Maybe we're not testing it in the right spot. Maybe I need to test it a little bit further over. That shouldn't be centered, or it shouldn't be 0 to 5. It should be like this one is. It should be up here. Okay, that's that one again. Huh, interesting. Okay, well. Does it go that would mean something else? Okay, there might be something else broken that's causing that. Unless this one's just a little bit different. So I believe if I take this one and switch the waveform, yeah, see it switches over. Wizard of Datums. You've got your own little wizard emote. Cute. All you need to do is get, I think, 2 buddies, 3 buddies to watch your stream for a month for a certain amount of time, and you can affiliate with Twitch, and then you can get your like a couple emotes out of that. You do have to have kind of a scheme. Bovinet subbed with Prime for 2 months. Aw, yeah, Bovinet, thank you so much. Yeah, so this is the, okay, so down here is where we're generating our waveform, right? We're doing all kinds of weird crap in order to create a waveform and then control it with control voltages. So that's what all this stuff is here to do. It's to combine the human controls with the, why is that so shaky? What is going on there? My hand is holding the camera. Why was it weird? Okay, anyway. Look at that. Look at all those little vibrations. What is that? I'm holding it with my hand. Something loose inside of my camera? That was really weird. I think the camera arm was affecting it, and it had a little like buzz like that. Weird. I didn't know it at the time, but I was in it for the emotes. Look, emotes have incredible psychological power. That's why Twitch is a successful platform. So we're generating our waveforms down here, and we're mixing it with the controls and stuff. And then I guess some of this stuff is spillover from this side of stuff. And our waveform then goes, both 2 of our waveforms go to a switch on the front panel, which is what is going on here. So one of these is the return path for our waveform, and it's the one in the middle. So they're doing it directly like a switch. It then goes on this circuitous journey. It sort of is going to Mordor. It goes up and down on the top and the bottom of the board, and it slinks its way down, around, and up and over. And it ends up right here. And it ends up right here. And right here is where it enters into the voltage-controlled filter. Now that looks off spec. What does the other one look like? They're both very weird when they get here, I guess. Or I'm weird. Yeah. Yeah, that is a little strange. I don't know what's causing that. Maybe it's just the differences between the 2 circuits. But okay, so then we go through a capacitor that's going to center these on the 0 line, because capacitors block DC. Hello? Is it a bad cap? Is that really what's going on here? Is it a bad resistor? Our signal dies when it gets right here. Let's replace the 220K. Maybe that resistor's what's wrong. All that understanding of the circuit, and it's just that resistor. But let's see if it just like decided to die right there. So I'll take the soldering iron, I'll make it real super hot. First you get the butter, then you make it hot. Granny's hot butter ice cream. All right, let's go to the microscope. Get the scope out of here. We don't need the scope while we're doing this. Okay, so over here, where are we? Take a left at Albuquerque. 1203. So I'm going to get a replacement resistor. Or wait a second. No. That is supposed to go to ground. Wait a second. Are we sure we are where we are? We are. Hold on. Let's before we get too far into that, let me just make sure. Let me take a look over here. I think I'm mistaking that input for the one that goes to ground, the filtering. Oh yeah, I should do something with the print soon. I think I'm at the wrong part of the circuit. I think that resistor capacitor are the input filter RC. No, they're not. No, they're not. Double check. No, I think I am correct in what they are. So our waveform is coming from, and again, like if I go to the right thing, we've got this one here, and we trace it down. Oh, see, there it goes through the RC, resistor capacitor. Somewhere around here, it gets out. Maybe I didn't mark it down properly. To filter, and this would be something else. So it does actually go through that. It comes down here and goes through that, and then up to there. And then I guess it comes all the way back over to here because it makes its way out and around. It's all right. We lost some of the data from when we traced that. I should have marked it down a little bit better. Because yeah, this waveform is coming from there, and it goes to there, and then it goes under that to here, down and over and across. It makes this little jumpy right there. And then it goes over and it hits the 74, sorry, an op amp. So probably an isolating op amp. And there's where it goes into this, which is where somehow our signal's coming back down. But we were able to trace it properly. I mean, I can pick it up right here. And I got it on these vias too. I was able to trace it on these vias. But then when it hits here, it stops on the other side of this resistor. It's a 1.2K, no, 120K. That's a big one. That's a big one for it to hit. But the signal doesn't go anywhere else. It goes in through that 120K. It is kind of baffling what's going on. I mean, there's nothing else that's connected to that capacitor, and it's not going to ground. It goes under the chip to where it hits this stuff. So by all means, we should have a signal here. And according to what we were just able to poke off of the board, we don't get signal. And that trace goes under the capacitor. It's deceptive. But if I ohm that out, and that's part of what we're doing here, is we're ohming out and we're testing the transistors. If this resistor just burnt up and that was the end of it, but I remember ohming it, so why is it dead on the other side? It doesn't make any sense, chat. This doesn't make any sense. I get nothing on this other side of the capacitor. But the resistor seems totally fine. Now 120K. And then from here to here, 0.4. I can solve problems, but I don't have knowledge. This is essentially an M303. It's a TB303. And then this goes under the chip, but it also goes to pin 1, 2, 3. Or was it pin 2? It's pin 2. It's pin 2. But our signal's dead on the other side of this thing. I can assure you that I understand just as little as you do. I don't know anything about what I'm doing. I'm sort of just feeling around with this thing and trying to make sense of it all. Everything seems to be fine right here. Let me put the resistor back. Although I guess I could use that as a cut and just test around. But we know that the signal gets to one side of this thing. We don't know what's happening on the other. I just feel like I want to pull all of the components off and just start selectively putting pieces of the circuit back in until it works. Just throw everything in a vat. There would be no reason that an alternate value would be put into this circuit because this is undoctored. I know 120K, but it's what is it in the original schematic? It's 220K. So we're roughly at half the value. And I guess part of it is that the waveforms are on a different scale. They don't resemble the Roland ones, which are documented right here as being an offset of 5.5 volts up to 12, and the other one's 5 volt offset up to 8. What we've been able to find is a wave that's right along the ground, and then our sawtooth is 5 volts off, but it only goes up to like 10. So the specifications for the waveforms are a little different. There's a lot of extreme similarity between the TB303 schematic that we have and the M303, but there are differences, which is the frustrating. This is very frustrating. I'm very frustrated, like mental breakdown frustrated. What is going into, I mean, like, we test here and here, we get nothing. What does that mean? It may mean that some parts of the transistors are shorted out or something. So if I turn power back on and I test here, oh, whoops, scope. And I test and I look at the circuit, and it's right here. We get kind of slightly altered, not very healthy looking wave, but it's still there. It's still the signal. It's gone through a lot to get here. And we test it on the other side of the resistor and it's dead. So I'm going to take the resistor out of the equation, turn the power back off, and I'll just cock this thing over to the side. It'll take a little convincing. If anybody here knows anything about the 303 and or has worked in an electronics shop repairing them, I can really use your help. Okay, so turn power back on. Nothing's exploding. Well, that's all the heat from the soldering. And then take my probe here. Look at that beautiful waveform. Nothing. So it doesn't have any kind of an offset. Hey, what's up? What you doing? Mystical rock hounding? So then, oh, well, now there's nothing on the other side, but here's this big 5 volt offset. Why is that there? Oh, 5.2 volt offset is because of the 5.2 volt source coming from over here. Paying my dues. Hope your Friday is good, bother. No, it's not going to be good. We already know that my day has been ruined, and it's been ruined by this 303. Censoring all the curses in the back of my mind. No, my day is shit because of this thing. Will not fucking cooperate. This is our 5.2 volt source that goes through a 1K in order to make sure that you don't blow up the regulator. And then it goes into a bunch of different stuff with different weightings on it. So here is an offset that goes into the filter, and that should act upon the waves that are coming in order to do something. I think it offsets it by, it sets it up and down. We're supposed to build up and push down the two different waveforms in order to put them into the diode ladder filter, transistor ladder filter. You said 303, coincidence? No. No, it's not. It was planned all along. We're working on an M303, so. Why you did this to me? Yeah, shit, here we go again, that's right. You've made your own 303 clones? I don't understand why this thing isn't working properly. I've been troubleshooting my buddy's 303, and there's just a lot of strife going on here, and so we're into the hardcore troubleshooting of the diode ladder filter, I think, where our signal has gone to die. More and more, though, the more I'm probing in here, the more I'm starting to suspect that these voltages being out of spec is in fact what's happening. Because while we can see a waveform and it does the right stuff, it doesn't have these offsets. But this is a TB303 and it's not the M303. So they could have done something different in their circuit to have different voltage levels. The fact that it's oscillating is one thing. Like, if there's no boost stage on this thing, unless maybe Q28 and Q8 are, first of all, present in the circuit, and second of all, broken. I'm not sure. This is like a circuit analysis nightmare land. These loops are crazy. And I do not know what's going on inside of them. I wish I had more information in order to troubleshoot this thing. But what I can do is look at the transistors and do a diode test on them. I think that's where we're at. I think looking at waveforms is going to further confuse me. But what I'm suspecting here is that when this waveform, this slightly deformed waveform, is applied to the ladder filter, it hits this. It's not going to hit it there. It hits this offset, but that offset's not doing anything. That are the capacitors bad. Maybe can I find, I don't know if I can find a 1 microfarad capacitor. We tested this with the multimeter. Here, turn off the power supply. Go into capacitor mode. Hit this thing up. Hit it up like your friend's sister. And it's 1.05 UF. If I test it on pads that aren't even its own pads, I get 1.05 UF. This capacitor is fine. That's the purpose of testing it on pads that aren't directly attached, because sometimes when you get just the right kind of cold solder joint, you can poke it with the probe, and that puts enough mechanical pressure on it to make it work again. Gonna knows his shit, which is why you test on other pads, and then it tests it through the circuit of the PCB. What are you saying over here? Let me read this. Believe it or not, I made some Mr. 303. Mr. 303 is a drum one, right? With original parts. Oh, that's cool. Oh, MR is different, isn't it? All these different 303s. Do you have a wave shape at oscillator wave shaper? Where are we talking about? The over where they join in with the switch, where it's got the oscillator selector switch, which are these pins have been reflown. I had to solder the headers onto the other side of the board so that we could use the IDC cables, the insulation displacement cables. And so as I poke in them, they're throwing out little bits of flux. But we get waveform here, and that actually looks like the waveform in the manual. That is at a 5-volt offset. Where was that one? It was here. 5-volt offset, and we get our little pompadour on top of the whatever it is. And then we have our wave that's selected, and then here we have our triangle wave. The triangle wave does not look like the one that's in the manual. Triangle wave is supposed to be offset by 5.5 volts. I don't know why it's not. And various other weird signals over here. There's our output. So if I flip the switch, this one changes. Triangle, square. That's actually what's both the pompadour on the square wave and the slightly clipped triangle are exactly out of the manual. That's why the 303 has its particular sound. It's because of those weird things. At the op amp. So you're talking about, well, I mean, over here we have, there aren't a hell of a lot of op amps, but there is a TL074 over yonder. We've already replaced this several times. See, Acid Labs shaved off the part numbers, and so we've had to use some pretty advanced techniques in order to glean what parts these are and replace the appropriate ones. Probing around, looking for stuff. That probably should have been at negative volts, huh? There's the positive. Badoo magic gold. So there's one type of wave. Oh, it's a test point. Is this the square test point? Ah, see, this is what happens to it eventually. It turns into that. But then, that's just power input. This is the 220 that they have you replace. Doing nothing? Nothing? How dare you? Huh, maybe that's the problem. Something or someone is dead. No. Huh? I really am just kind of probing around. I don't really know what I'm doing. But it's odd that this test point would have nothing going on. That may indicate that something is broken. Yeah, these break in a particular way so often that the engineers have a PDF file that details the things that need to be replaced when one of these modules goes down. And so we use that in order to replace a couple of the components. We also that gave us verification of what some of the components are. But then I plugged the thing in backwards, like as in the front PCB to the back PCB. I plugged in backwards, and that heated things up. It might not have done anything, but it might have also broken some stuff, some additional stuff. So we are kind of in the dark about what could possibly be wrong. Now, if the other waveform appears to be in spec, from what I understand, looking at just the triangle wave that sits here. No, but that one's not offset. Wait a minute. Not offset the way that I thought it would be. See, it's like at some point we'll find a component that's not soldered properly or a transistor that's dead, which is why I'm thinking I should probably switch over and just start looking at start diode testing transistors. But we can't verify exactly where this all goes wrong. We're not sure if that cutoff filter is just not getting a good signal in. I could make a signal to try to inject into the filter, and we could see if it comes out the other end. That's one way to do it. But in terms of probing around, I found the triangle wave. I haven't found anything relating to the square wave. I mean, you can confidently say any of a number of things that typically go wrong with circuits like this. Well, it's not a bad soldered connection because this was maliciously murdered. This device was murdered. The power was plugged in wrong because it's very easy to do so on the M303. And then I came back through and murdered it even more, but still. I killed it a more billion times. And we know that the tuning parameters actually do stuff, but they're still out of spec a little bit. I can start to tune this thing for 1 volt per octave, and we get the right-ish waves on the outset. We know that these are manufactured, or, well, circuits like these use 3904s. This one's in a weird spot, but it's got the right idea. It seems to be connected. I don't know why it's crooked like that. This transistor right here is in a spot where we've got this waveform that settles down to 5 volts when I probe it, but otherwise it's charged up to about 7 or 8 volts. And then it goes down like that, which is something that I saw probing in on the main waveform. Just getting an idea of what's around here. That's a 12 volt input. No waveforms from a dead circuit. It's a shame the failure mode isn't doing something crazy instead of just sort of not doing anything. Some of these might be excited from like control voltages and stuff that I don't have going into the unit. Others I might change the potentiometer position and get slightly different stuff. The op amps that I put in are new. It's really the that balanced transistor component. That's one of the ones that's a primary destructo piece. Well, like, okay, so all's well, all's whatever in this part of the circuit. I mean, it might be broken, it might not. Regardless of that, on the outset, I get a waveform that looks like, kind of like the proper thing, is just like slightly different from the specs. But the point is that I get a waveform. Like, I think, I don't know what to think, to be honest. Yeah, see there, it's changing frequency. Which one of these are adjustment for frequency? You got the, what is it, the service manual schematic? We're working in the service manual schematic. It's not exactly the same thing, but it is what Acid Labs used to design this module. See, I got the triangle wave there too. I got my hand on the knob. I'm moving the frequency knob, testing it. Maybe that the knobs are on a different part of the circuit. Okay, let's do some transistor tests. Well, I mean, seeing the tiniest little noise could be helpful too. Emitter Q8 square wave. Like the, where are we looking? Yeah, Q8 is the one that I kind of want to test, but I don't know which one is Q8. I would have to trace back to where our wibbling wave producer is. So if we can remember that I've still got the resistor in an off position going into, where's the filter? Let's just remember this. Remember that I did this, because I'll undid that. Does it look like I have Q and R markings? There is no silk screen on this thing. So I gotta find Q8. That's what I was getting ready to do. It's like, man, I don't know where anything is. I had to do this. I had to do this in order to figure out where stuff is. Here, where's my mouse? Hold on, hold on. I clicked it into DPI mode. What's going on here? Mouse, come back to me. There we go. I had to do this. I did this. And also, no, I will not be calm. I am going to be as boisterous and crazy as I can possibly be because I'm the only person here except for the dog. And I get to be crazy. Their Trongo looks like a... Oh, yeah, I already got that one. I'm going to be as crazy as I want because I need to be a little bit punchier because this is very methodical work that we're doing right now. And it grates on the soul. Anybody who lost a little bit of sleep last night is dead. They're dead. They fell asleep and their heart stopped. So I need to punch it up. Otherwise, we're not going to get through this in one piece. So I know that the leads going to the switches go through this crap right here, and I don't know what this stuff is doing. I need to figure out where these waves are originating from. We have a plus voltage test here, but then we have some kind of a really sharp triangle wave right here. So I'm going to go to the layer where we were marking down signals, which is this one. No, that's the lower layer. This one, yeah. Oh, this is the sort of tie it all together one. So yeah, this is where our signal originates from. It seems to go up to the upper layer because there's an output for the waveform. There's a waveform output like connector, and that's right. That's this one right here. I believe we're coming back down from that. As for the identity of all of the Q's and the R's, like, the 303 schematic is good for us communicating between each other, but it will be lacking when it comes to identifying specific things in this circuit. Acid Labs did a very close, what is it? They did a very close copy of this board of the M303, but they didn't use exactly the same stuff because they updated the design for modern parts. Yeah, proximity to the op amp isn't going to tell us like, oh, is that Q8? I don't know. Q8 because the waveform goes to the front panel and then back. It's possible that Q8 is like here. So I need to actually take a look at like where stuff is coming from and trace it out. So let's take a look inside of the oscillator a little bit more here. Oh, this is a mess. All right, so the easier to trace one, what's that one there? Coming down there. Something else. What is that? What the fuck? Oh, there's that. Oh, but that's decay. That's okay, so that's not the right stuff. All right, so we're back over here. We have a 5 volt. That's what that single bar through the thing is. That's 5 volts going into Q26, which is a matched pair. We have an RF chip that's 5 transistors that are super matched. So 2 of the 5 are being used in order to create an oscillator. Then we have 1, 2, 3, 4, and some kind of a FET. R100, 560 ohms going to the 5.2 volt power supply. And then C11 is a 1 microfarad 50 volt. So let's find a 1 microfarad 50 volt, and it's possible that our Q whatever is right next to that. So this is the 5 transistors. This one is the LM3046. Which one is that? 3046 is the transistors. So this is a bunch of the super matched and otherwise. One of those is dedicated to the what do you call it? The super matched pair, and then that goes up to the adjustment. So it seems like this one over here, the pin 1 and 2 and 3 are those thingamajigs. They're these. 1, 2, 3, 4, and 5 are dedicated to that cluster. So it looks like they're using 1 through 5. Here is Q26, and then that leads up to the tune and the width adjustments. So where's my pointing device? I need my pointing device. Where's my pointing device? Pins 1, 2, 3, 4, 5, that transistor cluster, and then up we go to where it gets adjusted with these 2 potentiometers here. So that's that part of the circuit. Vaguely identified, vaguely located. From there, we do have an op amp involved. That appears to be involved with this part of the circuit. What side of this thing is that? We've got a couple transistors coming out of this thing. And those are probably the remainder of the super matched ones, which makes sense because we've got a test point here for one of the waveforms. here for the finalized waveform going through this thingamajig, which is a 74C. So this is a TLO74. So here's the op amps. We got the usual op amp configuration, power and ground in the middle coming through there. I just heard a clicking noise, and it was the lens on the thermal camera, and I thought something popped when I poked it. You hear a popping noise when you poke something, and something like this kind of was a little scary. 220 ohm, that would break in a power surge. A bunch of 5 volt stuff. Waveform output would be here. There's no transistor here, unless it's coming in and using these. Maybe it's using these. One of these transistors is across here, and then the other two are these 6. So we don't know any other. What are the connections under the board there? Let's check it out. Ha, plot thickens. Okay, so the test point that we know that creates a good triangle waveform. Unfortunately, some of the layers are crashing into each other. This is actually under the board, but it's yeah, it's unfortunately kind of pooped out on top. It's a little confusing. All right, decoupling capacitor to ground, plus V over here, going out to, yeah, the plus V thing. No connection. What? Oh, is that an isolating amp? No, but these are, oh, this is the TLS74. So that'd be one of the op amps, and then the output's down here. And then I would assume that these two are tied together. So it would be plus minus out in this configuration. And so looking closely with power off, we can test that. Well, those are definitely not connected though. Oh, but I'm looking at the wrong chip. Yeah, we're over here. Yeah, those two are definitely connected. Okay, so this is a unity gain isolation amplifier. So that's where one of our waveforms is coming out of. It's, I believe, the triangle wave. So yeah, that goes down here and connects to pin 1. Pin 1 is part of, that's directly, there's way less stuff going on. Pin 1 is this. And I guess instead of all this hullabaloo, we're putting it into an isolation amplifier. Wait, what is this one? Tune. Tune's coming up and over and around, and it goes into that pin. And that's the same pin that we're putting into an amplifier that's in unity gain. It's not this one. So yeah, the 3046 is one of the ones that was sanded off, and we had to kind of figure out what it was without knowing anything, and then we got confirmation of what it was because we got that PDF that was the, in case of plugging power in wrong, replace this part. There's a lot of this stuff isn't here. I don't know why. Possibly they just lowered the complexity significantly of the wave shaper area, if you want to call it that. Which one is, okay, so let's, hold on, wait a minute. Pin 1 is one of these, isn't it? Let's double check that. Yeah, pin 1 is one of the collectors. And it's supposedly the collector on the left, although they could flip that if they wanted to. Because yeah, this collector on the left would be the pin that we were looking at. That goes to a tune trim, and then the other side goes to a width trim. Or no, that's not, there's no dot there. Oh man, this is why I don't do 4-way junctions. I don't do 4-ways. Don't do it. So I guess here it gets an additional boost, and here it gets an offset. So something is not giving it its offset, or it gets it eventually. The square wave is the one that I think is broken, but we haven't even gotten there yet. Q26 is a 5-pin IC. In the TB303, I don't think we have that here. Let's see, do we got any 5-pinners? I mean, maybe it's this. Let's double check that. Because it's starting to make a little sense that it might be this. There's a red line right in the way. C397, SOT323. SOT2235. LM397, I don't know. 10 pieces, blah, 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 blah. C397, single purpose voltage comparator. Is what I'm getting. The one singular comparator, huh? I don't think it is a voltage regulator. There's plenty of stuff for... Oh, I'm looking at the wrong type. 60 plus viewers. Yeah, we sometimes get crowds in here. And it's probably not because of the hardcore electronics lookup stuff that I do. I don't know if this is right. Screen. There's going to be no information about it here. These parts are very hard to look up precisely. I think it is a single comparator. I don't think we're making another power level over here, because we've already got this one all the way up here using the LM317 to make 5.2 volts. And that 5.2 volts goes all over the place. It's used as a reference in a lot of different areas. We have a bunch of transistors sort of floating around, and we also have the CD40 401068M, as well as whatever this thing is. HE416, whatever. All right. So we have test points that seem to do nothing. We have a waveform that maybe when it's in the right spot might go through the filter properly, but we're not sure. I've got parts that I replaced that were suggested by one of the engineers that made this thing, possibly V. And we have transistors that might be broken, but we don't need to specify and single out individual transistors that might be part of the problem. We can just go through and test these. And it would be nice if these schematics were exactly the same. It seems to be that they've simplified some stuff in some places. Other times they stick very strictly to the original schematic. But what I can do, apart from just sort of dead reckoning, aren't transistors too small to see with the naked eye? Well, these have a giant epoxy frock put on them so that they are able to be handled by humans and soldered together. Where is my scope? Where is my scope overlay? I need to get that out of the way so we can see what we're doing. What we could do is we could test individual components and make sure that they ain't blowed up. So what we do is we get our multimeter, we put it in diode mode. And in diode mode, we treat everyone like they're a diode. Are you a diode? No, I have no voltage drop. Is this a diode? No. But when we test diodes, we know that we get something akin to a 0.7 volt drop. So here, in order to get the diode to diode, it goes 0.6 of a volt goes through it. And I can test its buddy over here, this diode, but it's backwards, and it's getting 1.8 volts backwards. Maybe it's a Schottky, I don't know. Or I think it's just going through the other diodes that are there. A diode is a PN junction. You have two pieces of silicon mashed together. One of them has been doped. Both of them have been doped. I don't know, whatever. So that there's holes and electrons. And you get a boundary layer condition where you have a boundary layer of opposite attractions. If you add current to the right end and that signal gets, or that current gets large enough, your boundary conditions can meet up and make this thing conduct. It's all very physicsy. You can look up somebody else's explanation. They have animated pictures that explain it pretty clearly. A transistor is oppositely doped pieces with a third one on the end. And so when you hit that middle one, you're taking advantage of all those boundary conditions and you're bringing them in together to make everything conduct through. So you get a little bit of current coming from one end and a lot of bit of current coming from the other. They mix and they come out the other end. Or the opposite of that if you do the different, it's PNP, NPN, NPN, NPP, NMP. Would it help to cross-reference a modern clone circuit like the Behringer TD3? Maybe as like a forest for the trees kind of thing. That might be useful. But I mean, for the most part, we've looked up diode ladder circuits and we've looked up, the oscillator circuits and stuff like that. And there's while the minor details are different, maybe Roland found some specific things that they wanted to do and ways they wanted to shape stuff, and they do it a little bit differently. We know that this is a copy of it, but there's some of the other stuff around there. They're kind of changing stuff around. Yeah, so it's weird. Oh, that hot. What do I mean? What are you talking about? So we're zeroing in on it. I think our confidence level, this is very much a patchwork. This is very much a patchwork of knowledge. We've got a lot of knowledge about some stuff. We've got little tiny details of others, and we have assumptions being made about other parts of the circuit. The real way to get through all of this would be to do a full reverse engineer, get my own schematic, and work off of that. I don't have that, and I don't have that time. I really don't want to spend all that time on it. Maybe it'll be useful, but not really. We sort of can make suppositions about what should be where in this circuit and try to follow. One of the things that is concerning to me is that every time I look at a wave, it seems to come down from wherever it was. It moves around. The little tiny, high Z, the high impedance, the high impedance of this test circuit is too much for some of the tests that it is influencing what's going on in the circuit. So something is out of whack. That kind of tells me that something is probably kind of out of whack. The fact that we are getting waves at all means that some of the circuit is functioning, but the place that we've narrowed in on it is the place that's after the generation of the waveforms. I should be able to get some more like waveformy stuff if we can zero in on these transistors. I mean, Q8 might not even exist in this circuit. Or maybe it does. Maybe the circuit runs off and does a couple things and then comes back. That seems to be like what may be happening here, is that stuff runs off or goes through an op amp and then it comes back to the area. Yeah, the modern electronics, the update makes it a little bit more difficult. It makes it easier to build in source, but it also makes it so that our circuit might be functioning a little bit differently. These are all things you have to consider, and I am just giving you guys a window into my mentality here. You get a window into the bother mentality of what he's doing. I know a lot of this stuff flies well over the heads of people here, and I'm trying to explain to you that I'm in that situation too. This stuff is new to me. I'm learning, I'm getting to know it, but there are lots of gaps in the knowledge. Anywho, what we can do is we can test to see if these transistors have a 0.6 volt drop. So I'll give you guys this view, and we'll go to the micro because that'll make it easier for me to poke stuff. And we'll just start somewhere. I mean, if I just probe wherever. Now, keep in mind that what we're looking for is a diode to look like like this. So if I test from base to collector and I get the probes right, I should see a 0.6 voltage drop and not a short or an open circuit. We don't necessarily need to know what everything does, although the other parts of the circuit can influence this. So we know, because these things were designed by Satan, that the base is in fact this lower pin here. I think I made that joke, yes. I did the base joke yesterday. Internet lingo, you always start out using it ironically, and then it'll eventually weed its way into your common vernacular. Yeah, that one's fine. Mark that off the list. And I think most of these are replaceable with jelly beans, so if we find a broken one, hopefully we'll be able to put a 3904 in its place. We'll double check, we'll look up part numbers and stuff, but my ability to swap transistors has been a kind of a point of contention for me. I feel very unconfident about swapping around transistors. Oops, it's like this, like that, and then like this. That one has a 0.7. This one has a 1.3. Now it's possible that that's just the design of it. Maybe it's a MOSFET. But that one seems to have just fine of a voltage. This one's a little weird. Maybe I need to like reverse these. Oh, let's try it in reverse. No, that's blocking. All right, I'm gonna say that's a little sus, but I don't know. It's only a little sus. It's not big sus. What could it possibly be doing in this circuit? Hold on. Sorry, brain. There we go. Aha. What is that doing? You are biasing our signal. I think. Why would that do that? All that effort. All that effort. So so this is part of the error that I did where I accidentally did not flip to the bottom layer. So it's a little confusing here. Just think of this as a 2D representation. Our square wave, as it goes to the switch, is down here, and then it comes up to the top of the board where it meets up with this funky little circuit here. And it looks like we are voltage dividing and feeding back. Let's just write this down. I'm going to write this part of the circuit down because we'll see if we can find something familiar to us when we go to the top layer. But what we have is, and it's B collector emitter, right? Got that thing there. Hold on a sec. I just got to think. Is this is just a dot that I made. This isn't actually related to. Yeah, there's no via there. Okay. So our positive voltage is not involved in this area. This is a weird little filtery kind of dude. That's ground. The transistor, I need to remind myself of which pin is which. We did that over here. Where did I, CBE? Didn't I mark CBE? Yeah. ECB. ECB. So the emitter is here, where there is a capacitor to ground, very clunkily put in there. Emitter is there, capacitor to ground. Seems like they might be as frustrated as I am with these things. Huh. Okay, so if I have a transistor here, what is that going to look like? Okay, I need to... It may be that this is the damaged part with that kind of resistance that we get there, or that kind of, sorry, that advanced amount of voltage. Was it C, and then base is there. Why would our signal be coming out of the base? That doesn't make any sense. No, that's not the best. Sorry. It's, yeah, EC, emitter, collector, and then base is in the lower. Base is the lower one, so this would be the input down here, and that's clearly coming from, you know, another part of the circuit that we were looking at. So the coming out of this singular op amp, is that in unity? No, it's not. So anyway, that comes in and hits a bunch of filtration, and then it comes into the base there, and then this is pulling base collector emitter. So it's pulling out the collector. Huh. Maybe that is the part. And this is doing like a feedback transistor kind of thing. And here they're mixing, they've got a bunch of different weird values. Like, no, it's not mixing that. No, that's just your ground, and that's on the emitter. Yeah, if I write this down, maybe it'll be a little bit clearer what the circuit looks like. So let me see here. So I want my transistor here. Sorry, I'm very discombobulated when I do this kind of stuff. It takes a little bit to get your brain to work properly. So let's just say our signal's coming from the base here, and that doesn't have any other interactions with the rest of the circuit. So this would be the signal input. That hits the base of our transistor. The emitter is on the right side because the collector is on the left, right? Let me double check that. I can never remember this. That's why I write it down. Everybody's like, "Bob, there's such a genius." Like, no, I ain't smart. Emitter is up top. Okay. So we are emitting to here, which goes round the bend, and it goes to a 2202. So it goes to a 2202 and also a capacitor to ground. So we have our big cap to ground, and this would be a 1-off 50 volt. One-off 50 volt. And then it goes to whatever that thing is. $1501 or 10S1. So 1.5K. So 2.2K. And a 1.5K. Wait. I'm doing that. No, wait. 2202 is 22K. Cross that out. 22K. 1.5. 22, 1.5 in series. It's a very strange, I guess they're tuning it. And then it goes into the collector through a 102. So 10000. So 10K. And that goes to whatever the collector is doing. We don't know what the collector is connected to. That could actually, well, no, I don't think that's power. I don't think that's power because it ends here. It doesn't go any further. Or does it? And I didn't write it down. Hold on. No, okay, so that ends there. That doesn't go anywhere else. That would be kind of odd if it, it could be V. Having that be plus V would be, well, I guess maybe it's not. That does go to ground. Okay, so now we're at the collector, and we've got the rest of the circuit down. So we jump over to our waveform going out to the switch. And that's it. Waveform going out to the switch. So then that would be like here, like to switch. What the hell is this circuit? It's, what the, like, what it, huh? Oh, wait, does that branch off? Oh, wait a minute, that changes everything. That's plus V. Okay, wait a minute, that changes all our circuit stuff. It's all weird now, because those two are plus V. So now we have a voltage divider. Cross it all out, cross it all out. Cross it all out, none of it's valid. All right, so we're coming in here, coming in hot. Hit up the transistor, the collector, the emitter. I didn't give myself enough room, whatever. The emitter goes to, for some fucking reason, a 2.2K, 220K, 22K. So the is that the collector? Wait a minute. Fuck. God damn it. You guys got to get frustrated watching me do this. It's such a struggle. The emitter is up top. I've done this 3 times. The emitter is up there. So emitter up here, collector over here. The collector goes to this infernal voltage divider that comes from there, and it goes all the way to ground. So we have plus voltage going through a 1.5 and then a 10 1201. So a 1.5 and then a 1.2. So we have plus V 1.5K node and then ground, and that's a 1.2K. So we're like 10 volts, or like 11 point something volts. That goes to there. Weird. Oh, and then there's another resistor that goes over to the collector. Oops. Uh, 1002 or 2001. Which one is that? That's a one. The one has a little foot on it. So 10000. So 10K. We have a 10K coming in and going to the collector, and then the collector goes out. So I did this wrong already. I already messed it up. No. So transistor. The camera's like right where my hand needs to be. This is what it takes. You got to do a lot of revisions on your drawings. So how can I communicate this properly? Well, the collector has the 10K. So it's voltage divider, 10K collector. So it really, like, it would be over here. So let me move this over. I'll move it way over. So we got this as one of our sources. There. It makes sense that this would explode because this is right at the start of, like, V plus is just like right here. So 1.5K. And this one's 1.2K. And that goes through a 10K. But the 10K would have protected it, where it also hits the collector of our transistor, and the outlet of that, the emitter goes to a capacitor to ground, and a, what the fuck? 222.00, so 22K. So that goes to 2.2, and then capacitor. It's like a filter, little low passy kind of filtery kind of thing. But it's the collector that goes out to the output. This would be the input. So this is this area right here, and that could be the part that's broken, and it might be why our signal doesn't have like an offset that it might need. Very strange what's going on here. What are they trying to accomplish with this? Just hold on, let me just double check. So yeah, 10K and then a 1.2, 1200, and then 1500. So 1.2, 1.5 power, and then this has a 2.2 to power, and then a big cap to ground, and that one is on the emitter, which is the one down here, and then the collector, which is the one on the left, goes up to the connector as well as out to that circuit. So that's what we have right there. That took, and you guys can see this is reverse engineering. You come up with the values of the circuit, you stir it around your brain a little bit, you start writing it down. As long as you get it down accurately, everything will make sense in the end, and then you revise until you get some kind of a circuit that makes sense. And that's what we're doing here. So it's possible that this transistor is broken. I don't know specifically what this transistor is doing, and this is actually 12 volt NG. I don't know precisely what this thing is doing. It seems as though it's sort of just like repeating the signal again, but it's putting it through some kind of, it's hitting that filter, but that filter doesn't go anywhere. That's the frustrating part, is that filter doesn't appear to go anywhere. I've traced it on the underside of the board. So bring in the underside of the board. You can see 1, 2, 3 stops. And one of those stops is just a capacitor to ground. It doesn't go anywhere else from up here. And that one specifically gets it back to the transistor, to the two ends of the, wait a minute, to the two ends of the transistor. No, that's not, those aren't connected. So it goes to the resistors over here, to positive voltage over here. That's all it's doing. There's no other circuit connection there. Huh. So it's possible that this thing is responsible for the messed up waveform. Or it might be fine. It might be fine. The schematic for the M303, I think, is a totally different animal at this point. It's doing similar stuff, but it's doing it differently. Do we have like a... Oh, hello. So if this is a PNP... That's a 10K to a different... Yeah, it's really kind of messing me up that some of this stuff is... This is like, this goes to 5 volts. But instead of that, we have an a voltage divider. Jeez. Here, let's do a quick voltage divider calculator. Voltage divider calculator. I'm afraid this thing might be PNP instead of NPN. I guess I can revisit the diode test in order to figure that out. This one doesn't zoom in properly. Voltage 12, because we're in a modular synthesizer. First resistance 1.5. Second, 1.5K. 12K. Ah, there's our little buddy again. Our old friend, 5.3 repeating. 5.3 repeating sounds a little familiar to me. Why did I do that? Okay, it's 5.3 sounds a bit familiar. But where's the thing? Where's it? Oh, it was on that same... I've got so many tabs open, Chad. I've got so many tabs. Circle with a line through it. .33333333. So we've made a voltage divider before that 10K. We got a 10K in there just to keep us from running away in power. So is that a PNP or an NPN? Because here we've got, well, we've got a 10K going into this one, but we do have that RC on one leg of the PNP, and then we have a resistor of 10K, and that's our square wave output. What do we have over here? I don't see an RC filter on it, on anything. Yeah, we don't have an RC filter over here, but actually we do have this 10K that's bringing 5.3 volts in. Q24. I think the configurations are going to be different, but I mean, we've got our square wave and our triangle wave coming out of two parts here. Our triangle wave looks okay from what we've seen. Thank you. I appreciate the extra threes. And we've got 22K and a 1 microfarad, which is, in our case, we got 2.2. Is really 2.2 versus 20? Wait, what do we have? Did I do it wrong again? Did I mess this up again? 2202, which is 22000, which is 22K. All right, so it's not, they decided to bring it up a decade. So I think we found Q8. More or less. It's a little, you know, it's a little slightly different. There's some variation here. I wonder if this capacitor that we're hitting just before that is in fact the one that comes from the triangle wave. That would be over here. And then our triangle wave would be somewhere around here. Oh, there's a triangle wave. So we have a triangle wave. Comes down, or it comes from here, but this brings it down through a capacitor and over to our other, what you call it. We found, ladies and gentlemen, we got them. Okay, so that is the right structure. Okay. It's similar. It's not exactly the same thing, but you can see that, you know, our triangle wave existing in this point comes down through a capacitor and a bunch of resistors and comes over to the base. Is 5.3 practically the same as 5.5? Are they significantly different? In circuits like this, I think 5.3 is being used as a halfway offset point. If you take whatever voltage you're like the 6 volts, and you offset, I don't know, man. It works out in the math somewhere. But we do have a junction on this thing that seems to have a weird voltage on it. Now, this is supposed to be not an NPN, it's a PNP. So it's a PNP, and I don't know what a good equivalent value is. So it's actually, instead of that, it's the other thing. So that 5.3 goes into, yeah, it would be the arrow here, and this is not correct. And it just goes to there, and it would flip, you'd flip it the other way around. So in this case, it's we write it down again, just so we get the right thing. So in this case, we've got our triangle coming in, sawtooth or whatever, goes into the base, and then we've got arrow going in, and that comes from the 10K and the output. So out here is a square. Oh, it's going to look significantly worse. Is it supposed to be upside down? No, it's not supposed to be upside down. You can do the thing in, yeah. Squiggle. Oh, this one looks worse. 5.3 dot squiggle ground. Oh, it's terrible. 1.2, 1.5, and then on the emitter we go down, and we have a, I'll just do it like this, that going up, 12V, 12V, signal in, capacitor, capacitor, dot, and then ground, 1 UF, 1 oof, 2.2. Okay. Oh, that ruined my 1.2 tiny little K. Ooh, I should have written that larger. That was very difficult. It's the right thing now, though. Oh man. So we probably need to find a PNP. So 3902 maybe. Let's see if we can identify what this thing is, what this specific component is. So 3F with a little like Dune, the Dune E. Or no, that's the Dune D. Dunder cheap. Dune the D. Dunder cheap. I forgot the letters in it because I did a little bit in between finding it. 3F. SOT 23 3F. SOT 23 PNP. Good start. We got PNP right off the bat. Dunk. Get dunked on. Adam Plays rated the second one higher than the first, and I just disagree. I fell, and it might have been me being too tired. It likely was. I did not find the second one to be better than the first one. The first one had all of that cool sci-fi Vista-y kind of cool, like, and it's not like Villeneuve's not doing that in the second one, but it just didn't grip me the same way. I don't know. I was fascinated with the first of the new Dunes, of the new Dunks rather. The new Dunk City. So good signs. We found that it's a PNP. BC, so it's a like British part number, I guess. Is that what the BCs are? And then we've got a bunch of specifications for a transistor. What do they all mean? I don't know. I took quizzes on this and subsequently forgot all this bullshit. And you can find them in maxes and maybe like the hot zone where it switches. We could maybe even find some curves. But this is one of those multi-data sheets where there's like 65 different devices. Oh, there's no curves. That's weird. 65 different devices all in one data sheet, which is, boy, this stuff is just will peel the paint off of your walls. It's so exciting. 15 volts, NA, cutoff current, blah, 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 blah. Let's see if we can find something that resembles. So the 3F is the BC857. I bought one of those sample kits of transistors, and for the most part, I think it exists just to confuse me. So it's likely that it is some kind of a generic part, like a jelly bean part would do perfectly well. It's just on the day of manufacturing this specific unit, the BC blah, 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 was loaded up into the machine, and it was the cheap one to use. You know, that's like how this stuff works. Not many people are out on the fringes of their transistors, barely able to make what they're trying to make. Usually you're using something that is an equivalent of a jelly bean, what we call jelly bean part. Of course, I don't have the right thing. So all I need to do is find a sort of equivalent. BC807, BC817, 857. Well, let's just see which one of the BCs are. I got two BCs here. Is there a BC on the other page? No. 9012, 2N2222. That's really what they all should just be 2222s. I got 3904 and 3906. And we did see a ladder design that used the 3904. So the 3906 would probably be an acceptable substitute. But let's just see. BC817. BC817. The differences between these are all on the fringes. So we have on semiconductor, NPN, dun dun dun, BC 807, 807, 25 watt general purpose PNP. Oh, I did it wrong. It should have been upside down. Ah, I drew it wrong again. Both of my drawings are inaccurate. Don't look at me like that. Don't look at me like that. I'm not worthy. We found some weird behavior around the emitter of this one. From emitter to base, we got emitter to collector. Oh, is that what I was measuring? Wait a minute. We should do emitter base. Hold on a sec. Anyone still using vacuum tubes? There's only one non-Russian company left of the three that ever made them. At the beginning of the kickoff of the conflict, I made sure to buy as many vacuum tubes as I could stomach, because yeah, the ones I got came from somewhere around Ukraine, I believe. But yeah, I think there's only those. It's possible. Well, no, who is it? Noritake e-tron has made a low voltage vacuum tube component. So so from base to emitter. Oops. Okay, other way around. 0.7. So then, oh, this is fine. This component is fine. There's no need to replace it. We get 0.7 on both of those. It's a PNP, so it messed me up. This is the common component down here. Instead of being up above, the base is down below. So in a PNP, where's my marker? Where's my pen? What did you do with my pen? What's wrong with you, chat? I need my pen. I can't see without my pen. So it's instead, it's, oh wait, no, that is the same way. Oh, I'm dumb. Base, and then the one above it, pin 2, it's emitter. Yeah, oh, it is the same orientation. All right, I'm dumb. Dumb. All right, just writing that down so I don't screw it up again. But this component seems to be fine, so we don't have the smoking gun. Yeah, that's a Noritake. They have like a your current bitrate 0 is lower than recommended. What's going on with the YouTube? Why's my bitrate fucked? Hold on, let me take a look. We got upgraded internet. Our internet should be really good. I guess everybody's inside using the internet right now. Like everybody get inside and use the internet. It's a hot day. Where is my YouTube? Where's my Twitch thing? Twitch over here. Bitrate is not in the red. It's 6K. I don't know. Wait, why don't I get a better... I guess that's the max bitrate that we offer here. Over here on Twitch. It may not be much, but it's enough to broadcast electronics. Okay, so aside from my being a big dumb bastard and confusing myself while looking through these circuits, this appears to be operating correctly, except we should pin probe it to make sure. We're going to work our way back to the original oscillating elements and see if we can find a smoking gun, which I don't think we've found even close to that yet. But something's out of tune. So if I probe around, dead inside, go outside. It's been fine for you? Okay, that's good to hear. Thank you, Madam You. YouTube does have the better player, but Twitch has the community. I hate to say it to you, YouTube guys. You should definitely join us over on Twitch. Japanese. It's a Noritake. I don't know if I'm saying that wrong. Noritake e-tron or Noritake itron, whatever. It's phonetically spelled, and I've never heard anybody pronounce it. But they make a low voltage tube that I would love to put into a synthesizer module. Yeah, streaming and just the chat seems a little bit less. I mean, my chat seems to have quite a bit of... You guys seem like real people for once. But whenever I do like a YouTube stream and I watch somebody else doing it, it just feels a little bit more like your comment is just going off into ether. You know, on Twitch, people have like little conversations between themselves. Where did you say? Here, let's just look them up so that you can benefit from the coolness of this module that I don't know if I can get my hands on. That's how you spell it. Noritake Itron. I don't know how to say that. I could probably like pour over kanji and translate it over and see if I can actually like make it into something that sounds right. But they do like a lot of industrial screens and these VFDs, which are amazing. They look really, really good. But they take a lot of current. So it would be very cool to do a module that has a VFD on it just for that look. But somewhere around here, and I think it was maybe a press release. Oh, Korg has stolen it. Damn you, Korg. Fuck. This amazingly good idea of making a vacuum, something that uses less voltage and current, do the job that a vacuum tube does. I should have predicted that an audio company, a company that makes cool stuff, would come around and steal this thing. We had it from like a press release or something, but goddamn, that thing would be cool to make something with. But this is all Korg. It's all Korg e-tron. Oh no, you bastards. Where's my tube? Is it safe? Oh yeah, they have a very Japanese website if you go to the Japanese one. I'm overwhelmed with stuff. Is there going to be one from... It's like, I don't think I can buy this yet. Guide to VFD, new Noritake e-tron. Wait, what is that? Oh, this is just a screen. $385. Okay, moving on. Anyway, the new tube. There you go, new tube. You can get it from the DIY audio store for $50. How cheap. Corgitron. Barking internally, but also digitally. Motum analog modulator synth. Made some vacuum tube modules, but not so well known about tubes. Yeah, but for module, hey, Syphlet 8. What's up? I'm very frustrated. That's why I'm not concentrating very well. 41 months though. Thank you, Syphlet 8. Yeah, this thing would be awesome to make a module out of because it's less. It uses up less power. I was like looking at like VFDs and vacuum tubes and like Nixie tubes and all that stuff is not very good with modular synthesizers because you don't want to use a lot of current. You want to leave other modules to use up a lot of current so that your power supply doesn't get overwhelmed. And if this thing needs like 3 amps, you know, you're being greedy. So they call it the Korg new tube. Has it always been called that? How long have they had this? God, that's cool. You would just have this green glow. I kind of wish it wasn't green. I wish it was actually like the orange of the heaters. That's super cool. Should reinvent more tubes and use sockets. Well, I was always a critic of the tube. I always thought, and this is from my days at Aviom, AVIOM, hearing the engineers there argue about tubes and saying that, you know, there will always be, we have stuff that can simulate tubes now. You don't, you know, you can get the same characteristics. And yeah, that seems right. You can get the same characteristics. Well, a lot of places don't get the same characteristics. They don't bother to. And so if you use tubes, there are qualities to the tubes and the physics of what's going on with the electrons are different. And so it's hard to describe. You turn up the volume and it's not harsh, which is a little odd. It just feels like you're walking towards the booth at a big concert. Yeah, there's a charm, there's a sound, even apart from just the novelty of sitting down with something with tubes in it. There is a difference. And the reason that I know that is because I went, you know what? Instead of talking smack about tubes, I'm just going to get a tube amp. And so I went to Shit Audio because I'm poor, and I got a tube amp, and I plugged it in, got my nicest headphones, put them on, and I was like, oh, okay, so there's something else there. Something's going on. So I can say certified that I can notice something's a little different when you listen to tubes. But don't go, you don't have to go overboard. Don't spend too much money on audio. It's a limitless well of just stupid spending, and people get in their own heads a little bit too much with audio stuff. Whatever sounds good to you, perfect. It's not quite, it's more like appreciating incandescent light bulbs. It's like what all the hipster barbecue places do, where they put the big filament light bulbs all over the place so you can go, ah, warmth. That's it. That's what that is. That's what we're doing, but with vacuum tubes. Nothing else to it. No need to complicate it. So we can hunt around the signals in this area now that we know what it's doing. We know what it's doing. It's taking that square wave and taking the triangle wave, and it's turning it into a square. But for some reason, that square isn't quite in the right spot. And maybe it's because there's something wrong with the triangle wave. Triangle wave hates person wave. They have a fight. Triangle wins. Triangle wave. Oh, scope. Scope. We're over here. Oh, that is not a pretty triangle wave, but I guess that's what it does. Halogen light bulbs make good tweeter protectors. Huh. That's an interesting one. Okay, so this is before the capacitor. I guess this capacitor is what's giving our square wave its little, like, the dent in its head. Our square wave has a bit of a dent in its head. It's got a pompadour, and I guess this capacitor over here is causing that, because there's part of the pompadour. There's that side of it. Triangle man, he's person man. We have a fight, triangle wins. This wave looks fine. Wait a minute. 5-volt offset. That looks exactly like the one from the notes. So I guess everything's fine. Son of a bitch. This is that one. This is the common one. And this is our triangle. No, this is a triangle input. This is the common coming back from the switch. And this one's this thing. What? Oh, that's a weird one. I've never heard of that. Using a halogen bulb and a tweeter in parallel, I guess? So, okay, according to the notes, so then it is somewhere out from where we are. Oh, in series, okay. That's still kind of crazy. Okay, so over here, we flog the GIMP. We look at our schematic. I can't say, I don't know if you guys understand, like, I say stuff weird as a way to, like, be joking when I'm talking about things. So when I say something is, like, irregardless, or I say schematic, it's because I find it extremely irritating when people talk like that. It's a weird thing. Some people don't get that about me, and they end up thinking that I'm very dumb. It's something that, like, one of my best friend at this point originally thought that I was intolerable and dumb because I would say stuff in a weird way. I would say irregardless and, all that stuff. This is how I entertain myself when I'm doing dumb stuff like this. This isn't dumb. This is actually really fun, but okay, so our waveforms look like these. They really do. Yeah, I'm the most serious person on the internet. I do not make mistakes. All of my videos are perfect. And then I talk trash about everybody else. Some of those channels, man, the ones that can do no wrong and everything works perfectly for them at all times. Electronics can be kind of a bumbling affair if you're having fun. Our square wave starts at 5 volts and it goes up, maybe not to 8 volts. It's sort of supposed to go up to 8 volts. Let's get a closer impression on that. Let's move this down. Oh my god, move it down, and then we'll move up. I want 8 volts, but this is like a weird. This is in very fine. I'm twisting a knob very carefully in order to get. Oh my god, what is happening here? Operation disabled. What did you think I just tried to do? What is still disabled on my scope? There we go. Oh, I'm glad it's kind of snaps a little bit there, but we should be getting up to that 8 volt mark. So let's take a look. Right here, this one. We're getting above the 8 volt mark, which I guess that's not super bad. My theories were revolving around it not being enough of a signal. And then our low point should be above 5 volts, which it seems that we don't really have 5 on the scale. 5 volts. And then the next one, this one should be 5.5 to 12. What? No, this one. Wait a minute. What? Wait, what? Why did you, Moss to Bruce, why do we fall? Why did you fall? Why did we fall, Master Bruce? Bruce. Why would we be? To get ourselves back up again, Alfred. What the what? So if I look at it on the switch output and I switch it, it's still down there. It's still down at 0. How does this one look fine, but then the one coming literally off of the same structure look totally wrong? And if I go over to this circuit over here, this is coming from right here. Other side of it is below 0. That's this here. And these over here. There, it looks like that. There we've got 0 to 10 volts. Filter. Output of this. Input. Nope, that's giving pulses. Yeah. Yeah, if it's too low to get into the filter, but the square wave is in spec, and if we hit the filter with the square wave, we don't get any output. So is it in the wave generation? The wave generation might be okay. Use polyfuses as tweeter perfectors, but it's better and less fun. Yeah, the way to do it with like shoestring and glue is oftentimes a lot more fun. And you get that beautiful little indicator that you have to look out for. Otherwise your tweeter explodes. I don't think that's smoke coming off of this thing. I think it's just dog hair. Yeah, so like, you guys got triangle waves? Because I do. Here's the thing. If I turn this off and turn it back on again, it seems like... Oh, no, I didn't wait long enough. Turn it off, let the capacitors discharge. Turn it back on again. Ah. Yeah, is it getting hit with something like leaking through and mixing it with a negative signal? Could it be -V is leaking through a component? That would make a certain amount of sense. Whoa. All right, we got to diode test some other stuff. I don't think I put that in backwards. It just, yeah, I mean, we're making a wave, right? Like a lot is going right. A lot is going right in the circuit. We're making a wave, and even some of our waves are in spec, but something ain't happened the way it's supposed to happen. And I don't want to trigger that triple T bot. It's just my friend and I used to reference that all the time. Now that's a FET, so that's not really going to show up quite the same way to the diode test. That's the part that I don't understand the most, is that the square wave looks totally fine. The triangle wave is humping 0 volts, which doesn't make any sense because the triangle wave is being used to create the square wave. Triangle wave comes in here and feeds down into the base of this transistor, where it becomes our square wave. I don't know how that works, but this isn't like, if you drew this more logically, again, this is something that I used to do, and for 10 years I did this. You would redraw this in a sense where it starts on the left and it goes to the right, right? This is just all out of order because they put all of the controls on one side, and then they kind of squished all the different elements of their synthesizer into blocks. And so as a result, having this be splayed out over a distance is not as efficient. So they threw it all together. This is the FET right here. This is a MOSFET. Hence the right angle things coming out. I think 2SK30. Let's look that up. What was that? 2SK30? N-channel MOSFET, 50 volts, 6.5 milliamps from Toshiba. How is a MOSFET making a triangle wave? That seems impossible. Is it that we're making pulses and the pulses are hitting this FET and setting it off, and then it charges up and discharges a capacitor, and then that trigger goes into our square wave generator, where it takes samples of that and it uses it for high-low, trigger high, trigger low. 10K, I believe, is what's sustaining the ramp, right? You can connect an LED across the polyfuse. Huh. Doesn't that mess up? Shouldn't that be messing up the... Yeah, pulse to the cap to discharge, and then that creates the triangle. And Q28 is responsible for setting all of that off. So Q28 is more than likely... would it be isolated on the other side of the op amp? It should... I mean, that must be Q28 right there. But then we have... this would be the discharging capacitor. This is the one that's making all of our beautiful waves right here. So that cap is responsible for both the square waves and the triangle waves. Although there is another capacitor here, and we have an op amp somewhere in the mix. So over here, this one is 3F. This is another a PFET, or sorry, not PFET. It's a PNP transistor. This is another 3F with the Dune B on it. Done dirt cheap. 3F. So that's not what this is. This is not a MOSFET like in the big synthesizer. Is there a... Oh, hold on, I clicked on something. I accidentally clicked the mouse by moving this thing around. Is there a MOSFET hiding somewhere around? That's another PNP. There's a lot of PNPs on here. A lot of different circuit elements sitting around that I don't know what they're doing. So it should be here somewhere in this vicinity, and it's not. When you say check R105, I don't have 105. It's like R101. 100K, R118, 105. So that would be, I don't even know where that one is yet. Okay, we can find it though. We can find it. It's close enough to everything else that's going on that we can find that. So R105 is likely this one, because we go from the capacitor, we have the two resistors on the capacitor, and that has, wait, pull down or pull up? That is a pull up. This is like a massive voltage divider. It's a very strange circuit. Hold on a minute. Other capacitor over the op amp. And then, oh, minus V is right here. Okay, so that would make 10K to ground. To ground, not to minus V, but then this is there. I think this circuit is quite a bit different. I don't think this is a MOSFET. I think what they did is instead of a MOSFET, they have an op amp doing something. They have a single comparator sitting in the circuit. So we look up wave shaper circuit. And we look to see how these structures differentiate from one another. That's confusing. What else would you call it? Maybe triangle and square wave generator. Huh. Yeah, people are using it. Oh no, it's a sawtooth, sorry. Everybody wants very simple circuits. I'm trying to look up something that's more akin to what Roland did. I don't know what the terminology is on that. Do you want a sawtooth generator circuit diagram? No. See, and it's like this uses logic gates. It's not quite the right thing. It's tough to kind of track these down. Because, yeah, variable resistor, 5 volts into the top. We go into some weird-ass thing over there. Not what we're looking for. Maybe I would need to go back and study a little bit. I think Moritz goes over some stuff like that. I'd have to look around in order to gain a little bit of confidence around them. Because I didn't expect we'd go back into the wave maker. Everything looks okay, except that our triangle wave, for some reason, is on ground. It shouldn't be on, not on ground, sorry, yes, ground, on ground. It's at ground, our 0 volt location, which is an odd thing for it to do. But maybe well, no, that's not what it's supposed to do. It's supposed to be offset by 5.5 volts. Even still, I don't think that is the core of the problem here, because we've got a good square wave, and we can send the square wave into the penis ladder filter, this thing over here. Where is that? Where'd that go? Which is just a way to use voltages as resistance using the reactance of the capacitors as well as the diode properties of the not diode switching, but the actual like real diode properties of the transistors. We're using not the instant switchover sort of thing. We're using it as, I don't know, voltage controlled equivalent thingies. But the point is, this filter is not functioning properly. Our waveforms look good on the square wave. The triangle wave seems to be broken. There might be something influencing that, or it might just be my lack of knowledge. Maybe there's a good triangle somewhere else in the board. It seems like that may be beside the point. we need to refocus on this. I don't know how much more stream I've got in me. This is very stressful. I had to do this. It's personal. I need to get this thing working. And it seems like we're digging ourselves deeper and deeper into a hole. Because, like, right here, the entrance to the filter, what the hell is that? What is it? What huh? It seems to have already gone through a capacitor before it gets there. I don't know where that cap is. Which, this is supposed to be our waveform should be here. We should be seeing our waveform right now. So if we're on triangle, everything is messed up. This whole thing is made out of, it tastes like hurting. So we flip it over to our square, and our square is still kind of messed up. It hasn't gone through a capacitor yet. Dr. Noisemo! Now there's a screen name. How you doing? Why does it look dumb? And act dumb? And be dumb? Why be dumb? Could it be that I don't have anything plugged into the output and that's somehow... No, that shouldn't be it. They wouldn't have those switched to ground. I really appreciate being able to watch a real problem get solved. I'm learning so much watching this. You know, I never had the benefit of sitting around other people messing with circuits until I got the IED job. And then I learned just an absolute like wealth, like volumes of information about troubleshooting and things like that. And you know, it is a mindset to get into, but you know, eliminate all of the things on the sides and then zero in on what's going on in the circuit. There was a lot of this stuff that you know, I just didn't get any exposure to. And yeah, I appreciate you guys liking this on that level. And listen, I sound frustrated and emotional. That's because I'm purposely getting frustrated and emotional, because watching a robot do this is not as fun as watching a guy get shouty that stuff's not happening correctly. There's a difference, and one of them is hamming it up for the camera. So if I were working on this alone, well, I'd probably be asleep right now if I'd be taking a nap. But if I were here alone and working on this, it would be a lot of poking around and a lot of just looking stuff up on the internet, right? Yeah, that's what it's supposed to be. The 303, the Roland TB303, has a clipped sine wave, and the square wave has a bit of a pompadour. So you can see that it's not, they didn't draw it as a true to form. It's not, this isn't a piece of scientific equipment. These sound cool. And then that goes into a switch, which is all the way over here. Here's the waveform selection switch. It seems a little weird to me that you would switch it like this instead of like activating pieces of the circuit, but I guess instead they decide to have them always active and it's switched over here, and then it comes back and it goes into the penis ladder filter, which is a bunch of transistors that are being used because of their properties regarding to reactance and the ability to act as a voltage controlled resistor. So that's that Moog sound, that I mean the Moog sound, the sound of Acid House comes from these waveforms as well as the properties of this filter. These are the primary components of an Acid House synth. However, I don't know what the fuck's going on in this thing. Look at this fucking thing. This is ridiculous. And I've read up on it, multiple websites, and I still don't know, because that word reactance, I think, is just a big blanket over properties that could be explained in a little bit more simplistic language. It's a low-pass filter transistor ladder. Or you could also do diode ladders. I was working on building a module from Hajivo that was diode ladders. These transistors are hooked up just to short out one of the junctions, and so you're left with what is ostensibly a diode in the penis ladder filter. Low penis filter, yeah. But our filter is doing nothing, and our waveform gets snubbed almost immediately. We know a lot of the stuff that's around here, and we know what the signals should look like. The exit from the switch is, well, I think it's over here, but there's some additional filtering that happens. But we know that our square wave is good, even if it does this weird stuff. That's coming just from 0. So I don't understand why it almost immediately gets knocked down from this. this goes over to the switch, and then it becomes this, which is boring. Why would there be nothing here? There it is. I guess it goes through this cap here, and it gets destroyed. So if it goes through that cap there and it gets tamped down, if I flip the waveform, yeah, see, we're not seeing a proper triangle there. The triangle is off. And it's weird because the square wave is generated from the triangle. So if the triangle's off, I guess it's still triggering the whatever is making it into a square wave. But that's so weird. What does the other switch do? This thing? Oh no, that just changes another part of the... Yeah, that doesn't affect anybody. See how it kind of settles down? I don't like that. I think that might be part of the broken part of this. I mean, we really should be finding like a smoking gun, like a component that does not work. But we're not really finding that. Here's where it enters the filter up here. I have gone through the trouble, those of you that weren't here earlier, I've gone through the trouble of taking photos of the top and the bottom layer of the board and overlaying them on top of each other in GIMP. So we flogged GIMP until it was just having the best time. And so now we know where this stuff is going. We know where our signals are fluttering around. What up, Thunder? So I know that my wibbly signal, my wibbly wobbly lines, are coming in, or they're coming out of this pin header here. That's what that arrow is signifying. Up and around on the board, it's sort of dodging all kinds of stuff as it makes its way up and around and into the filter here. I get a square wave on one end of this resistor, and on the other end, nothing. What was the big brain move? The time that I said a bunch of internet words? So in comes this square wave that we know is in spec. Goes up that via, goes to this resistor. From there, it only goes through a capacitor to where it joins up with the rest of the circuit. What that circuit looks like is the totally comprehensible and not at all penis-shaped transistor ladder filter. We come in, we go through the resistor here, we go through the capacitor, and then to the balls, because waves are stored in the balls. But our signal disappears right here. I know the mouse is kind of difficult to see. It's just right below that resistor. Why does it disappear completely at that point? It's like it's mixing with some other element that just kills it. Oh yeah, that was we did that back in the IEDs. If something starts to get really confusing, you basically take yourself out of the equation. It's the same principle that I apply to running the machine shop. Is if I could possibly make a mistake, I don't do it. Hey, I'm gonna go get my print. I'm gonna switch that around and then put that in the light. I'm running out of daylight, actually. Maybe we'll just use... Well, no, I'm going to put it on paper towels on the windowsill. Let's get these out of here. We did a print quality test at the beginning of stream that only took a little bit, but I've got kind of distracted. Oh, did I leave the lid off of that? Oh boy. Uh-oh, stinky. Uh-oh, stinky. Don't want to leave the lid off of these things. It means all the air inside of this thing is toxic as shit. If only I could get a machine that would do this. Too bad nothing exists. Alright, so let's get these out of here and put them on a paper towel. I'll put the paper towel on the windowsill where they can cure a little bit more. I'll take all the benchies out of here too. Might as well. I got a bunch of failed benchies. This really doesn't smell that bad. I'm not wearing the respirator right now. And I'm not even getting a smell. Possibly because the fan's taking it all away. Well, that's why we have the silicon mat. I got some on my hand. Let me go get a paper towel. Yeah, forgot to get two. One for my appendages and the other one for the prints to go on. Ooh, it's stinky over here. That's a little worse. Contain thy smell. All right, these, damn it. I put them all in a paper towel, and then I folded up the paper towel to pick them up, and then I just let go of one side of the paper towel like an idiot. Dumb. All right, let's get up. Fuck! Son of a bitch. Let's go up here. Oh, there's not going to be much UV up there. Oh well. We'll let them sit for a little while, and they should dry out at least. And then we'll get to see the true power of the Saturn III. Oh god, there's all this stuff in the way. I really need to clean up this shop. We were going to do a clean up shop stream, but it's too personal. I need to get this synthesizer fixed because it's been weeks that we've been working on this thing. You know, if I had all my ducks in a row at the beginning, it takes a long time to figure out what you should do. And now we're figuring out what needs to be done. It's crazy. What's that? I forgot that you used to work with IEDs. I used to I used to do this stuff. And there's no way that a project like this should last this long. Although Synthesizer is pretty significantly more complicated than some of the things that I worked on. Let's see the print. It's got to dry off and cure a little bit. It's got to dry off and cure. I shouldn't handle it at the moment until it gets exposed a little bit more. Okay, where am I going? I'm going over here. Okay, so, yeah, my signal dies like immediately. Where? I mean, it just goes to pin 3 of that chip that we replaced. We have a new chip in there that should not have immediately died. We put a new one in there, and we know that it's the right value. We know it's the right chip now that we've verified it. It might be, there's a couple variants of this chip, so maybe this variant performs a little differently, but it's not down to no signal. It shouldn't be down to no signal. Now, we've also come in over at the other location. Sorry, we've come in over here, which is where 5.333 volts comes in. And we get what I have to assume. Where's my... we need a voltage average, and we'll take... How do I change channels on you? Settings. Channel 1. Camera 1. Camera 2. Camera 1. Camera 2. Camera... Hey, get out of here. Get there. Getting the tiny little Xbox on that thing. Okay, so we come over here, and we measure our 5.333 repeating. Wait, why is it still on channel 4? I guess there must have been an OK button that I missed. Come on, setting. I need to get a crappy little, like, IP camera or something that I can set up as a Willow checkup cam, because I'm worried about that puppy. She's upstairs. She'll be fine. See, I just set it to be channel 1, right? Source, channel 1. Get that. Where's the OK? It didn't change over here. Channel 1. Ugh, maybe I just remove them. Remove, and then I do a measure, and then we do VPP. No. Are you a top or are you a base? Vamp? Nah. V-average. There it is. There we go. Okay, V-average. That was easy. So now this should be 5.333333333333. 5.31 is good enough for me. Okay, so like that voltage is fine. That voltage is fine. Let's get this out of here. More room for signals. I don't like that the number line changes sides. What drives a man to be neutral? That starts at 0. Oh, that voltage measurement is still there. That's what that cursor was. So just remove that. There we go. Now I won't get an annoying cursor. Used to work with IEDs, yeah. As in bombs, yes. We reverse engineered IEDs that were sent into the FBI Engineering Center, and we were the boffins that would analyze them. See, this is what, there's like a weird charge up going on there. And by the way, we tested this capacitor and we got 1 microfarad. And we tested the resistor and we got the right value. And these weren't tested directly. They were tested from other pins. I do not understand. I'm going to put that resistor back in and show you guys what's going on. Actually, I'll do it right here. Do it from this view. So turn off the power. That's an important one. Wake up the soldering iron. Tweezies to help maneuver. And this 1203 gets scooted back into position. Just kind of give it the nudge. Give it a little nudge. I'm very frustrated with this thing. It's one of those, everything's fine, I'm broken. Maybe one of the chips I put in like immediately broke. Man, I'm hearing a lot of birds outside. What the fuck's going on? Maybe there's a cat. The times that I've seen Window Cat, the famous Window Cat from a long, long time ago, I don't think Window Cat's around anymore, but well, Window Cat was a cat that used to visit and show up in the window here. It was really awkward, very strange. I got a couple pictures of Window Cat. It was kind of funny, but I think, well, no, sorry. The indicator for it was that the birds would go absolutely nuts. Like every bird in the trees would be tweeting up a storm, because I think they were all warning each other that there was a cat nearby. Cats being like total like murder robots for birds. They kill an insane number of birds per year. What I was doing there is I was just adding some lead, adding a little bit of leaded solder to this, even though I didn't really have to. It just makes it easier if there's a higher volume of solder for me to just kind of go over this and make it not look like I was drunk when I soldered it, although it does still look like that. All right, so that being said, if I turn power back on and I test one side of this thing, I get nothing, test the other side, and I have a waveform. Like, what is that? Is it maybe so minute after the resistor that we don't see it? Like, that is no longer the waveform that we were working with. What the heck? Is something coming back through the other part of the circuit? In reference to this, maybe the capacitor being in the wrong direction? Because yeah, once it hits that, it doesn't do anything. It's just gone. And we really should be seeing a waveform over here. Which, I mean, we do see a waveform, but it is not what we expected. What if I mess with the knobs over here? Hold on. So let me poke in on this location right there, and then mess with some of these. This is a frequency though. Okay, so that, I mean, something's happening to our waveform because as I... Oh no, never mind. That was just me slipping. I'm slipping. Nah, none of these are doing any. None of these are doing nothing. I'm thinking like something else is like feeding back and eliminating our wave, but it's just too strange. I genuinely confused as to why we would have waveform here, perfectly fine, everybody's happy, and then it becomes a millivolt blip on the other side of this thing. Yeah, but the thing is, I mean, pay attention, like over there, millivolts. This is like nothing. This has been reduced to nothing. And what really should be happening is that it would be possibly reduced quite a bit, and then this would center it around the 0 volts point, which, you know, here it's just gone. Here it's weirdly reduced. Is there some element of the circuit that I don't know? Because we even pulled the chip to see what the traces underneath were doing. So we know exactly what's connected to where. My document is accurate. So we know these connections from underneath. So we go down and over, and then that skips over that end and brings us over to the 2.2K that goes up to our 5.2 volt supply. And that's supposed to be like an offset. You're supposed to, well, that's creating sort of 2 offsets from your signal that then feed through the filter and go back into a comparator. Why you know work? I mean, I can pull the chip again. Let's do a little diode testing on the chip itself and figure that one out. Because maybe something over here is just so messed up that it's killing everything. So what I need for that is the multimeter, and I need to turn power off on this thing, and I need to pull up just my little picture of a transistor so I don't get turned around. Actually, no, not the picture of the transistor. I need the picture of the component. Go. And then get the scope out of here. Shame I can't have like the multimeter be up on screen like that. I'm sure I could buy some kind of multimeter to do that. Okay, so over here, I need the microscope. Microscope makes the probes look bigger. Makes my probe look huge. So we are on pin, what are we going for? Pin 2 to pin 1. Whoopsie daisy. Backwards. Flip it. Continuity? Wow, wait a minute. Is it that we're discharging the capacitor, or is this an actual broken component? That ain't good. It doesn't even like charge up for it. Let's try pin 2 to pin 3. Well, reverse it. Ow, poke myself. Draw blood. These probes are extremely sharp. That's why I use them. They get through any oxidation. Oh, I'm doing ohms. I see. Oop, there we go. We're in volts. We should be in volts. Be in diode mode. Yeah, these are sharp enough to draw blood, which is why I use them, because they poke through oxidation. Very nicely indeed. Okay, so anyway, now that we're on the diode tester. Okay, overload. Try this. Oops. Still overload. Flip it. Flip it. Come on, I saw something. No, it's still overload. Stop beeping at me. 1.5. Ah, this thing might be broken. Might be broken. I'm thinking that maybe the chip is broken. Maybe if I pull the chip, it's possible that pulling it before has caused. No. Is that your blood sugar thing? No. Okay, so there is one diode which makes up one of the transistors, right? Or similar structure therein. 0.7 is a good number to have. I flip over to here, and I get bad. That may be it. So I go from this pin now. Ooh, but I get the same thing on this one. And then the other end, I see it's fine. This may not be broken. This might be in fine shape. So then I go from here, this is another base, to either one of these, or maybe the other way around. MOSFETs are the ones where you can get like a short circuit because it's being switched. I'm having weird results on this one. Yeah, it does say, like, the results of my probing just now seem to indicate that there are in fact two diodes that make up the transistors. I tested, you know, pins 2 to 1 and then pins 2 to 3. Then I did 4 to 3 and 4 to 5, and I got 0.7-ish volts. It's just one of them, 2 to 1 base to collector, appeared to have a lot of volts to activate it, which may not be all that strange. That may be just fine. How's the app now? It's so, like, the advantage of the app is that I don't do anything. It just manages itself. And I don't have to think about corrections and stuff like that. I can still do that, but I don't have to. It'll eventually bring me back down into normal range. So, like, I had like a calzone thing for lunch. I knew it was 30 carbohydrates, told my pump I was eating 30 carbohydrates. It's handling everything from there. My glucose level will spike, but it'll come back down as fast as the insulin will make it. So it's kind of amazing. The only place I could go from here is to get faster acting insulin. Faster acting insulin is not necessarily covered by the public health plan that I'm on. So I may be SOL on that one. It would be nice if I could get the doctor to justify it and get me super hyper fast acting insulin. There's a certain type of insulin now that's like super amazingly fast acting. It'd be nice if I could, like, manage my healthcare and lose weight and all that fun stuff. Anywho, like, the more I look at this thing, the more it's like situation normal, like nothing is wrong. If I pull the entire chip, I guess we would be able to look at, well, but then maybe this stuff is what's influencing those waveforms to become nothing. But I don't understand how we could reduce the waveform to fucking nothing at this junction of the resistor. I don't understand that, because it's taking a waveform and blotting it out. Like, that's not how this works. Let's look at that 3D print, see how it turned out. It hasn't exactly been sitting in UV, but it should be drier by now. Most of the alcohol is probably cleaned up. And then I'm going to give up. I'm going to give up, and I'm going to put this thing to the side for a little bit. or work on it tomorrow. I'm not really sure, but it's gotten way too interesting, so I'm too invested in it. Oh, it's like really cloudy out, so it hasn't gotten direct sunlight. At least it'll have a chance to dry off. There's so much fucking stuff over here. I can't even get to the window. That's relatively dry. It's probably not fully cured, but you're not fully cured without a smile. All right, there you go. Whew, look at that plastic. Look at that. What was that? I'm like in the midst of cleaning up, so there's shit all over the place. So apart from the fact that I snapped it in half, some of the parts seem a little, yeah, it's a little drippy. I don't know if that's resin or alcohol. That seems like resin. So I could probably do a little better to clean it off. There's too much stuff in the way. Hold on. Scope. Out of there. Move this up so that I have room. So yeah, I snapped it in half by accident, and I could have done a better job cleaning it. I think that might be resin. But even down to the pinhole, that is crazy. Holy. I don't know if those probably go all the way down. Hard to see with all the crap around. I could do a better job cleaning it. Cones are like properly spiked. We got midline holes through stuff. This thing is nasty accurate. Look at our cones. Nasty. And then the steps on the cones are looking good. I'm gonna have to wash my hands with alcohol when I'm done. I wash my hands of this with alcohol. Is that supposed to go all the way down? Oh, and I think it does. Oh, Jesus. This is the Saturn III Ultra. And there's a Saturn IV out too, so it's like not the best, but it sure works well. Oh, there we go. There's a little bit of the little oopsies. Oh, and I can see oopsies on the undersides of those blocks too. Yeah, this pushes it. It's not called torture test for nothing. At least all these lifted really nicely. Yeah, the tiny orphan details like this. Oh, it's still soft. It needs more UV time. Needs more UV time, but it looks good. If I can get it off the build plate without, you know, fucking blowing it up. Hey, that's pretty cool. I'm impressed. The person who wanted to see this, I don't think they're around anymore. They left. They're dead. But yeah, torture test passed. Now I'm going to throw this thing out because it's covered in fucking nasty resin. I didn't clean it off properly. That's on me. Probably would have let it soak longer and get a second tub and do the second tub wash so that it gets a little cleaner the next time. All right. I'm done. It's 4:30. How long did it take? To print that, I think it was like 55 minutes. Like when something is wide, it's not that big of a deal. It's just when it's tall, it takes longer. Yeah, it was like an hour. It was like a 1 hour print. And then it has to sit and cure for much longer than that. So but yeah, now I know the limitations on overhangs. Maybe I should print another one of these just so that I can properly get it off of the bed and then actually wash it so that I have a good example of what the printer's capable of. Let me spool that up right now. Let's spool that up. I just tell it to print it again. Go. Send and print. So yeah, 52 minutes and 5 seconds it says. but it might take less time than that. I don't know. The printer, I don't know if it listens to the slicer. I think the slicer just gives it slices, and then the printer handles the rest on its own. But they seem to have a discrepancy between the two, because it said the other one was going to take like 3.5 hours, and it only took 2. So I don't know. Torture test. Click OK. I'll need to figure out the art of getting stuff off of the print bed. Benchy failed. Benchy failed multiple times. It just simply would not break off of the bed, whatever it is, the bed liner, the bed plastic. So, man, I wish it was easier. I wish we had an easier time figuring out what was wrong with the synthesizer. But once again, this thing appears to have broken me. We can trace the signal all the way into the filter. It hits that first transistor. It should hit that first transistor, but it appears not to. It comes in, and there's a 120 kilo ohm resistor. It's a pretty big resistor. That would squish our waveform down to be very small indeed. But it wouldn't stamp it out. It wouldn't completely kill it. And it appears that it completely kills it. It's not a millivolt signal anymore. It's nothing. I mean, I could replace the resistor. We are measuring it with not a waveform. We're measuring it with ohms. Maybe there's, but that's ludicrous. That's completely ludicrous. That there would be some kind of a weird, yeah, it's 110K, 119 actually. It's very close to the value. I can test it on pins that are not it. 110K. I could even go over here and test it on this. That's the wrong one. Which one goes over to the... Which one of y'all goes to that fucking thing? One of these will read 120K. There we go. So the added resistance of the trace gets it to a cool 120. And I'm not on the resistor. I'm on other pads that are associated with the resistor. So why does it die on the other side of it? I can measure from the other side of it. I don't think that capacitor's doing it. Our waveforms are in positive DC, and we're going into the negative end of the capacitor. I did not touch this capacitor. So this thing was working, and then it blowed up. So something like the capacitor is the wrong way. That's not really a thing. It shouldn't really be the case, because those are installed from factory. And we can see pictures of other people's circuit boards too. M303 PCB. There's a resistor. It goes into the positive end of the capacitor, just like in mine. And then it goes to a censored chip that nobody knows what it is. It's a bunch of transistors. But yeah, ain't that weird? Yeah, these are some of the components that kill these that you have to replace. But yeah, ours seems to be making waves just fine. I do not understand. Do not understand. 2-0, the war isn't over. I know. It's like it's a struggle. Every day, I'm just trying to survive out here. All right, I'm gonna start pulling my hair out and like begging and pleading and like crying like Avocado does over this stupid circuit not working and me not understand what wrong. I don't know what's wrong with this thing. It's really annoying me. It's like I could pull that chip. It is one of the things that we keep replacing. If I pull that chip, but I don't think it was dead. I don't think that chip was dead. And the specifications for this transistor should be very close to the ones that were there originally. It shouldn't be killing that. We get 5.3 volts where we should get 5.3 volts. Maybe if I probe around some of the other resistors here, outputs off, okay. Probe around, like this is 1K. Sorry, 100 ohms? Oh yeah, 1000 means 0 zeros at the end. 2.1, this would be the 5. Oh no, they're both 2.1s. 13K. This is the weird one where they combine the two. So 15 and 100. Why am I getting 13? Did I read the 5 wrong? That doesn't make any sense. There should be 15 and 100. Oh, 15 and 100 making 13K, right. Right. I'm measuring, they're in parallel. 2.2, 2.2, 5.6. I think that should be 5.2. 5.6. Oh, there's a 5.2. They're all... whole gang is here. Yeah. Okay. Buy a working one so I can throw this one into the fire. Yeah. They're not cheap. No, don't add that in, you bastard. Oh, that's not what I'm looking for. M303 modular shopping. $700. $10 from Lab Supply. I'm really curious what's going on with that. I really should have spent $10 to see if I would get an M303. I don't think I would. Because yeah, these are $600, $700 pieces of equipment. So I really would very much like to fix this thing. And at the rate we're going, I'm probably going to have replaced everything. MOQ is $100. Maybe swap in an MOQ. Modular synthesizer stuff can get very expensive, which is why I love Hajiwo, who is a YouTuber who makes and gives you the designs of modules that are incredibly cheap. Now, he may say they're worth like a couple bucks, but that's not the case. You need a lot of other stuff for them to be cheap, so probably just a faceplate. Yeah, there's a lot of stuff on that faceplate. Minimum, oh, that's right, I had to buy $100 in order to find out that it's actually just something that's mislabeled. Could you imagine though if you actually tried that and you got 10 of these things and you could sell them all for $600? Oh my god. I don't know if anybody's buying them, but anyway, all right, that's it for me. I can't keep going. My brain is collapsing and I'm starting to see ghosts or something. Everything sucks. I can't believe we're still fucking stuck in the same part of the same synthesizer. This is the same thing, only now we have a little bit more knowledge of the stuff that surrounds it, and I sort of have a good idea of where that waveform is coming from, but we can see plain as day that this thing is at least making one of the waveforms properly. That square wave looks good. Triangle wave might need something, but for right now, that doesn't matter because that filter isn't doing anything. If we could get that square wave out the other end of the synthesizer, then that would be great. We would actually be able to troubleshoot the sawtooth wave rather pretty easily. But I don't know. I'm getting beaten by this M303, and I'm not one to suffer defeat. I will keep hammering away at this. I just don't want to subject you guys to the type of sort of white whale pursuit that would ensue. You're all gonna, it'll get to the point where you guys are shaking your head going, there's something wrong with him. What is wrong with him? Because that attitude is what's gotten me to a lot of the big solutions around here. Father does amazing stuff. Well, that's because I can't let go of the chew toy. I just can't. It's horrible. Anyway, I'm gonna stop doing this for a minute and kind of rethink things, or maybe just let my brain cool down until I figure out what to do next with Dave's synthesizer. The next stream we do, I don't want to work on this. It is getting very interesting and stuff is really cool, so we might. But I would like to pull something else out and actually work on, you know, like Burn the Subs needs to be done, and it's a little bit more straightforward. Burn the Subs, the revamping of it starts with me going to Node-RED and plugging chat into Node-RED. And when I do that, I can have more chat interactivity things that we can just, you know, day to day, we can just do cool stuff with that, right? So we'll think about that. I want to think in that direction. The 3D printer is perfect. That was almost a non-project. Like, this thing is printing incredibly well, and it got through the Thingiverse resin torture test without a single hump. I'm going to put a little bit more care into actually cleaning off the one that's printing right now. So I'll clean it off and I'll get it all nice and, you know, gussied up so I can show you guys it next stream, which will be Tuesday. Until then, I have a adiabatic factor LAN party to get to. So I do have an ultrasonic cleaner. I could try that out. It's in the other part of the basement. I haven't had good use for it. It sounds like a bunch of dentist drills thrown into like a junkyard dryer. So I think what I don't know if I'll use the ultrasonic to clean the one that's printing right now. I don't know. Unless I move the printer all the way into the back of the basement. Might have room for it. I'll have to think about that. Okay, anyway, thank you guys. I really appreciate you joining me on this Friday. We had a pretty good crowd. Unfortunately, I didn't have anything like cool to show off aside from, you know, getting into my head while I'm working on something like this. Maybe somebody learned something, but we'll see. LAN Party the 90s are calling. Listen, when you get to a certain age, you need to change venue in order to game for a sustained amount of time. So it'll be the longest game session that I've had in months, only because we changed venue. It's very important to do. It's sort of a staple, but yeah, you know, hey, LAN parties are great. Anyway, I will catch you guys later. Yeah, LAN party. There's only 3 of us. It's barely a LAN get together. What did I come back to? I'm talking about what I'm doing this weekend. So I'll see you guys on Tuesday. I'll see you folks on Tuesday. I shouldn't like gender you guys. There's all kinds of weirdos. Until then, catch me on Discord. Here's the end card. Dirt, 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 dirt. I hope my friends like adiabatically. The air goes over the mountain. I hope they like that game because streamers seem to like it a lot, but things are hit and miss. I will catch you guys on Tuesday. Join the Discord. You can find me there in the meantime. And uploads. I'll get back to uploads. I'm a broken man right now. When I can stand up on my own 2 feet, I will start uploading again. I have about 120 left to go. So until then, I don't know. Be prolific or don't. I don't care. But I'll see you guys on Discord. Where's the button? There it is.